Long intro. Hello, here we are. Hello, hello, hello. This is Dr. Garrett Smith. Screwing up my intro, but that's okay. No, otherwise known as the nutrition detective around these here YouTube parts. And I know many of you are very excited for this show today. It's going to be, as I have become known for, one of the barn burners. This is going to be a long one. We're going to be going through how nickel feeds and is necessary for most of the big pathogens that we see out there today, the fungus, the yeast, the bacteria, and then there's even stuff with viruses, if you still believe that those exist. So we're going to get into all of it today. There's no pressure. There's no pressure on me, none at all. But here we are, and let's get into it. So super chat stuff like questions and stuff. I am not even going to touch any questions or super chats until maybe the end. And if we are at 4 hours or whatever, there's probably not going to be any questions unless I absolutely cannot help myself because I have a problem. Anyway, let's get into it. I'm going to be opening these docs as I go. Some of them might be, I have the whole document. Oh, Joe put the Word doc in the chat. I'm going to be going through it as well as I can in order. I didn't even open up the windows preemptively because I was late and I wanted to get this out there close to on time. It's 10:13. We're supposed to start at 10. Here we are. So good things are worth waiting for, right? So let's get into it. I see that Kelsey's in the chat. Hi, babe. And we will get going. So here is the document that I made for this. Now, 6 pages long. We have a lot to go through. We're going to start with, I'm going to give you an overview of nickel and pathogens. We're going to go through these links first. So let's head into that. And I'm sure people are going to say, wait, my doctor never talked about nickel or anything related to any of these. And I'm going to say, yeah, nobody's talking about it except me. There was if I can find it when I'm going through this stuff, there was a worldwide conference on nickel in something like 2016, and nothing came of it. Absolutely nothing came of it. What you'll see as we go through these papers, maybe not today, but maybe in the next show, is there's a distinct thing where they'll say nickel is bad. Well, they'll keep saying they think nickel is somehow essential to humans, but they never spell it out ever. And then they'll say nickel is bad, but then nobody ever does anything about it. And then they'll kind of like not talk about it. Like in the cadmium and nickel with the COOF in the urine, they found nickel goes up, but they try to only talk about cadmium. They try to not talk about nickel. It's very obvious. And you'll see magical words like dyshomeostasis and nickel balance. And you'll see all the phony ass words that they talk about when they're trying to hide a toxin. So let's head into it. So we have the role of nickel in microbial pathogenesis. This is disease creation. Role of nickel in the disease creation process of pathogens, right? Microbials, they're probably referring mainly to bacteria there, but let's just head into it. Nickel is an essential cofactor for some pathogen virulence factors. So I'm going to hit on the word virulence first. Virulence means how it becomes bad for you. It'd be like saying like a person isn't, I'm going to try to do an analogy here. A person isn't that virulent until you give them a knife or a gun. You make them much more dangerous. You may take them from not being dangerous. Like let's say you had a child that wasn't dangerous and you put a gun in their hand and they become dangerous. Right? That's virulence. It's like when we say everybody's got Candida in them, but not everybody has a Candida problem. Do you understand? The Candida became virulent. Okay? So when you hear this, nickel is an essential cofactor for some pathogen virulence factors. Then you go, okay, so if this is how pathogens become dangerous, what should we take away from the pathogen? Duh. Nickel, right? Okay. Due to its low availability in hosts, pathogens must efficiently transport the metal and then balance Balance. It's ready intracellular availability for enzyme maturation with metal toxicity concerns. So nickel is so toxic that it can even be bad for the bacteria that are trying to use it as a weapon. The most notable virulence-associated components are the nickel enzymes hydrogenase and urease. We talk a lot about dehydrogenases, and we'll get into the urease part. Both enzymes, along with their associated nickel transporters, storage reservoirs, and maturation enzymes, have been best studied in the gastric pathogen H. pylori, a bacterium which depends heavily on nickel. It has been estimated that half of the world's population has H. pylori in their gut. Pay attention here for you molecular hydrogen people. Stop asking me about molecular hydrogen. I don't want it. I'm not adding what they say is the most potent antioxidant known to man to the system, which is directly anti-dehydrogenase. Molecular hydrogen utilization is associated with efficient host colonization by the helicobacters. That means they efficiently infect or infest, if you will. They use molecular hydrogen to do that, which includes both gastric and liver pathogens. Translocation of an H. pylori carcinogenic toxin into host epithelial cells is powered by hydrogen use. The multiple nickel-iron hydrogenases of Salmonella, Enterica, typhimurium are important in host colonization. When you think of Salmonella, that's one of the things you think of, while ureases play important roles in both prokaryotic, Staph. Anybody heard of Staph? And eukaryotic Cryptococcus genus. Those are fungal pathogens associated with urinary tract infections. I'm going to get into the urease in a second. Other nickel-requiring enzymes, such as nickel acidoreductone dioxygenase, ARD, nickel superoxide dismutase. When people out there say copper superoxide dismutase, manganese superoxide dismutase, nickel superoxide dismutase, I want you to understand that yes, there is a zinc superoxide dismutase, and even good minerals have to be kept under control. This includes iron and zinc. But superoxide dismutase is a protective thing against that mineral harming you. Free metals are generally not good. Okay, and nickel glyoxylase play important metabolic or detoxifying roles in other pathogens. Nickel-requiring enzymes are likely important for virulence of at least 40 prokaryotic and 9 eukaryotic. So this is bacteria they're talking about, prokaryotic, and then there's fungus that they're talking about. Pathogenic species as described herein. The potential for pathogenic roles of many new nickel binding components exists based on recent experimental data and on the key roles that nickel enzymes play in a diverse array of pathogens. So they're talking about binding nickel to starve the bad guys. Okay. With I'm going to hit on the urease real quick here. The urease, they're going to bring this up a lot. Bacteria especially need, and so do some fungus, as we'll see, urease. What does urease do? It does two things for these pathogens. It breaks down the urea, which then gives them nitrogen as a literal food source. And it creates ammonia and carbon dioxide at the same time. The ammonia is not good for us, but ammonia helps alkalize the environment around them so they are not damaged by acids. Okay? So urease is critical to certain bacteria's survival and virulence in terms of becoming bad for you. One of the ways they do that is they make a lot of ammonia. So let's get into, just remember, 40 bacteria and 9 fungus. Gastric and liver pathogens. Okay. Oh, this was a good, did I, hold on, let me see. Is this the one I highlighted? I thought I highlighted one, but maybe I didn't. Okay. Metals in fungal virulence. So fungus, right? Metals are essential for life, and they play a central role in the struggle between infecting microbes and their hosts. In fact, an important aspect of microbial pathogenesis, disease creation by pathogens, is the nutritional immunity, in which metals are actively restricted, or an extended definition of the term, locally enriched by the host to hinder microbial growth and virulence. Consequently, fungi have evolved often complex regulatory networks, uptake, and detoxification systems for essential metals such as iron, zinc. Those can be helpful, but then we get into copper, nickel, and manganese. Why do we keep finding those three bad guys all together? So let's see. Thus, we compare the common and species-specific mechanisms used for different metals among the different fungal species, focusing on important human pathogens such as Candida albicans, Aspergillus fumigatus, or Cryptococcus neoformans, but also looking at model fungi such as Saccharomyces cerevisiae, that's brewer's yeast. I don't suggest you take yeast. Or A. nidulans as well-studied examples for the underlying principles. So this one is kind of really basic, but if you want to get the whole paper, you can. That one was not as useful as I thought. Maybe that's why I didn't highlight it. I still had it on my, come on, Elsevier. Let's do this. Come on. There's no CAPTCHA challenge. There we go. There has to be, so they're saying, as I was learning, there's the ostensible reason for things like these CAPTCHA things on science sites, and then there's the real reason. The evil reason. So they say they're trying to protect things. The question is, why are they putting all those CAPTCHAs everywhere? Why are they putting them on search engines? Like literally, I go into Brave sometimes and it puts a CAPTCHA that I have to act like I'm a human when I've been accessing this website over and over and over and over. What is the secondary purpose of it? So let's go find on this one. This one is nickel impact on human health, an intrinsic disorder perspective. An intrinsic disorder perspective. That's interesting. Oh, let me see. Why is it not showing my highlights? There they are. So I thought the highlights here, we'll hit the highlights. Nickel exerts both positive and negative effects on human health. Go and try to find the positive effects. Go and try to find them. Nickel binding proteins are involved in cancer and allergy. Nickel in microorganisms modulates their pathogenesis and the role of microbiota. Many nickel binding microbial and human proteins are intrinsically disordered. How about we just say if there's a lot of nickel binding proteins around, you're sick? Wouldn't that be easier? Oh, whoa. How did that just happen? That was strange. Sorry. Elsevier's map. Why is it doing that? Okay, I'm just going to read it then, since it's not letting me highlight. The interplay of the presence of nickel and protein disorder and processes affecting human health is the focus of the present review. So they just said it's necessary for health, right? Many systems involving nickel as either a cofactor or as a toxic contaminant are characterized by large disorder. Systems involving nickel, large disorder. The role of nickel in the biochemistry of bacterial enzymes is discussed here, covering both the beneficial effects of nickel in the human microbiota. We'll go over that. The thing is, I'm going to tell you before we get to it, lactobacillus are nickel sponges. So you're literally soaking up nickel into your lactobacillus and pooping it out. It's one way you try to get rid of it. But anyway, we'll get to that. That's in the research. As well as the role of nickel-depending bacteria in human pathogenesis. That's the one thing they can say. Nickel in the human microbiota. That's the one beneficial thing they can theorize. And I'm going to tell you that it's actually the human microbiota are pooping it out. They're helping you get rid of it. Kind of like parasites and toxic metals. In addition, the hazardous health effects caused by nickel exposure to humans, namely nickel-induced carcinogenesis and allergy, are triggered by non-specific interactions of nickel with macromolecules and formation of reactive compounds that mediate cellular damage. So let's just move on from that one. So they've known about all this stuff for a very long time. What's this? Nickel chelation therapy as an approach to combat multi-drug resistant enteric gut pathogens. Wow. Multi-drug resistant, and then nickel chelation comes in and saves the day. Well, why don't we start with nickel chelation instead of multi-drugs that ruin your gut? Now, I'm going to disclaimer here. We're going to talk about dimethylglyoxime. We call it DMG, but you need to pay attention. If you go on like Amazon or iHerb and you search for DMG, you're going to get, let me show you. I'm not telling you to go buy this. I want to be very clear here. If you go on supplement sites and you hear me talking about this and you go, oh, I'm going to go buy some DMG, what you're going to buy on supplement sites is dimethylglycine. It's not dimethylglyoxime. Okay, look at this word, glycine. That's an amino acid. What we're about to talk about, glyoxime. Okay, so I am not telling you to buy this. I am not telling you to take it. I'm telling you for your own safety, if you go and start looking to buy DMG at supplement sites, they don't sell it. Okay? So, this is when people, and oh my gosh, do not, for those of you who are adventurous, maybe too adventurous for your own good, and maybe that's why you're sick, because you've done stupid things in the past that didn't pan out. Okay. The nickel test solutions. If you go to like nonickel.com or whatever, if you buy a nickel test solution, it has dimethylglyoxime in it. It has very strong alcohol in it. And it has literally ammonia in it. They say to use it in a well-ventilated area. So if you go and you start drinking nickel test solution, I have nothing to do with that. I have nothing to do with any of you taking DMG, dimethylglyoxime. I have nothing to do with that. So when you hear this, I'm not saying to take it. This is a study. So my disclaimer is done. If you choose to take some information and run with it, that's up to you. Okay, here we go. I was on the wrong tab. The nickel-specific chelator, dimethylglyoxime, has been used for many years to detect, quantitate, that's count up how much, or decrease nickel levels in various environments. Addition of DMG at millimolar levels has a bacteriostatic, as in it stops the bacteria, on some enteric pathogens, gut bacteria, including multi-drug resistant strains of Salmonella, typhimurium, and Klebsiella pneumonia. DMG inhibited activity of two nickel-containing enzymes, Salmonella hydrogenase. Again, we like dehydrogenases. We try to help our dehydrogenases. Bacteria like hydrogenases. And Klebsiella urease. We just talked about both of those. Oral delivery of non-toxic levels of DMG to mice previously inoculated with S. typhimurium led to a 50% survival rate, while 100% of the infected mice in the no DMG control group succumbed to salmonellosis. So they injected whatever the salmonella toxic brew was. Do I think it was just bacteria? No, that would be like saying, like, vaccines only contain one thing. No, they don't. So half of the mice that they infected with this toxic brew that had Salmonella typhimurium in it, 50% of them survived if they got DMG. 100% of them died if they didn't get DMG. Gosh, guess nickel's pretty important. I mean, DMG, dimethylglyoxime, is very specific to nickel. Pathogen colonization numbers from livers and spleens of mice were 10 times reduced by DMG treatment of the Salmonella infected mice. Using nuclear magnetic resonance, we were able to detect DMG in the livers of DMG orally treated mice. Another one, inoculation of Galleria melonella wax moth larvae. So that's what they infected with DMG prior to injection of either, multi-drug resistant Klebsiella pneumonia or multi-drug resistant Salmonella typhimurium led to 40% and 60% survival, respectively, compared to 100% mortality or death of the larvae infected with either pathogen, but without prior DMG administration. Again, DMG saved basically half of their lives. But it's a bacteria. But wait, they didn't say that these mice were nickel poisoned. They didn't say that the moth larvae were nickel poisoned, did they? There was nothing about that. They were just probably fed the normal diet. But when they gave them a nickel chelator, when they infected them with this toxic brew, half of them survived. Wait, does it make sense that maybe Salmonella typhimurium and Klebsiella pneumonia, the multi-drug resistant stains, might require more nickel to grow them? They like it so much. Our results suggest that DMG-mediated nickel chelation could provide a novel approach to combat enteric pathogens, including recalcitrant, that means they don't respond to treatment, multi-drug resistant strains. Now, there was something I wanted to find in here that Kelsey pointed out to me. Where was it? Chelator toxicity. Was the DMG toxic to the mice? A group of 8 mice, they got the following DMG treatment. These animals displayed no obvious toxicity symptoms. In another experiment, they got another dose. Again, these mice displayed no toxicity symptoms over the course of chelator administration or for the next 3 days after cessation. After they stopped the chelator administration, mice were then euthanized. So they had a little problem after that, but that was because the researchers killed them. That's just thought I'd point that out. That the mice were fine. Okay. Again, I'm not advocating anything. I'm just pointing stuff out in the research. So let's get into the next part. Let me go move tab to another window. So let's go to nickel and immune suppression. So I wanted to hit on this real quick. As I say real quick, right? Am I ever really quick on anything? I mean, I'm good at running, but sprinting. But other than that, I talk a lot. Anyway, I just wanted to hit on this. Okay, a lot of the diseases you're going to see when we go over them, they will talk about this shows up in immune compromised people. They will very specifically, a lot of these pathogens grow. They call them opportunistic infections, or they call them, it happens in immunocompromised people. Well, I'm not going to spend too much time on this, but here we have the immunologic effects of nickel. Suppression, part 1, suppression of cellular and humoral immunity. That's like most of your immunity. I went over this in another live stream. A single intramuscular injection of nickel chloride causes significant involution, or like the thymus is turning in on itself. Okay. Nickel chloride predominantly affects T-cell mediated immune responses and natural killer cells. Okay. You want your natural killer cells in your T-cells. Immunological effects of nickel, 2, suppression. Immunosuppression. Suppression of natural killer cell activity. So I'm not going to spend too much time on this one. I thought this was interesting. They did a single injection, significant reduction in natural killer cells. Another in vivo correlate of nickel-induced natural killer suppression was observed in mice injected with the melanoma. Mice given a single intramuscular injection of nickel chloride developed significantly greater numbers of lung tumors than saline controls. The results indicate that nickel chloride is a potent suppressor of natural killer cell activity. And then let's hit on this last one, the immune effects of nickel. The most consistent immune effects are suppression of immune responses. So why are all these immunosuppression researchers not looking at nickel levels? Well, they would look at nickel in the blood and nickel in the urine and go, well, they're within 95% of the people out there, so therefore they're not nickel toxic. It has been shown that T lymphocytes and NK cells are more susceptible to nickel toxicity, they use the word, than our B lymphocytes or macrophages. Our studies demonstrate a clear difference in the natural killer cell between nickel tolerant and intolerant individuals. Isn't that interesting? In particular, natural killer cell activity is reduced in sensitized patients respective to the normal subjects, and the addition of nickel has immunotoxic potential. Doc, how much nickel does it take to make me get toxic? Just enough, especially to push you over the edge. And if you take nickel with, let's say, a leaky gut causing irritant, lipopolysaccharide is one, endotoxin, retinoic acid is another one. So retinoic acid plus nickel, you got the leaky gut causer, and then you got the nickel. And the nickel by itself, you get enough of it, causes leaky gut. So you can get toxic to nickel just from the nickel. But if you have nickel plus something that causes leaky gut, then you get problems, even bigger problems, even faster. So does it make sense that if people are already nickel toxic, that they would have a bigger problem with nickel being added because they don't have as much room for fitting in more toxic crap? They try to remember, it's not nickel sensitivity. They say nickel tolerant and intolerant individuals. This would be like saying fragrance tolerant and fragrance intolerant individuals. The fragrances are bad for everybody, but just because some people don't have a reaction to it doesn't mean it's okay for them. It just means they tolerate it so far. Following me? Okay, so that's the immunocompromised part. Let's move this to a new window. And here we go. Cryptococcus neoformans, which is, so I wanted to hit on this so you guys can hear the diseases that go along with this. This is just a basic list. So Cryptococcus neoformans, this is a fungus. We got meningitis. There's lots of lung stuff with this. Disseminated cryptococcosis, so just fungal stuff everywhere. Opportunistic infections of the central nervous system, lungs, skin, and other organs, particularly in immunocompromised individuals. And then this paper, let's hit on this paper now. Is the nickel-dependent urease complex of Cryptococcus the pathogen's Achilles heel? Does that sound like a scientific paper, or does that sound like almost the author's trying to say, look, stupid, like this is how you fix this? Immunocompromised, opportunistic infections, nickel-dependent urease complex, the Achilles heel. You know what Achilles heel is, hopefully. If you don't know what Achilles heel is, I'm going to leave it up to you to look that up. The nitrogen scavenging enzyme urease has been co-opted in a variety of pathogenic organisms as a virulence factor, most notoriously to neutralize stomach acid and establish infection by the gastric pathogen H. pylori. The opportunistic fungal pathogen, Cryptococcus neoformans, also utilizes urease as a virulence factor, only in this case to invade the central nervous system via the blood-brain barrier and cause life-threatening meningoencephalitis. So it literally has an accompanying nickel transporter. NIC1 is responsible for most, but not all nickel uptake into the fungal cell. Mutants of the core urease protein URE1, accessory protein UR7, and transporter NIC1 are all attenuated, as in turned down, reduced for invasion of the CNS of mice, and urease activity may directly affect integrity of the tight junction. Where do you have tight junctions besides your blood-brain barrier? Oh, your gut. Of the endothelial cells of the blood-brain barrier, the network of proteins that limits paracellular between-cell permeability. Leaky gut is also called intestinal permeability. This work highlights the potential of urease, its accessory proteins, and nickel transport as potential chemotherapeutic targets. So when they say chemotherapeutic targets right there, they're saying a therapy that is a chemical. So they're trying to say that they think they could fix this Cryptococcus problem by targeting nickel with a drug, a chemical, chemotherapeutic. So we normally think of chemotherapy with, cancer. And obviously nickel goes along with cancer, but they're literally saying we could fix the nickel problem and starve the fungus. Okay. Let me see. Was there anything else? Nope, nothing else. So that's Cryptococcus. Let's get into black mold. Wow. Aspergillus niger, as in Niger referring to black. And Candida, because a lot of studies, they were looking at them together. So we have a Candida albicans can be a fungus or a yeast. And we have a mold here. So we have mold, fungus, and yeast all wrapped together. So what can black mold cause in people? Well, other than mold toxicity syndromes, we got fungal ear infections, allergic fungal sinusitis. So did you know a lot of people who have chronic sinusitis, it's not bacterial. They keep giving them antibiotics and it doesn't kill them because they literally have a fungal infection in their nose. What's keeping the fungus alive? Oh, I don't know. Maybe we'll figure it out now. Pulmonary aspergillosis, aspergilloma, invasive aspergillosis in immunocompromised individuals, and opportunistic infections. Wow, there they are again. Wait till you see how much these things love nickel and copper. Crazy thing. Candida albicans causes oral thrush, vaginal yeast infections, cutaneous candidiasis, that's candida infections of the skin, esophagitis, urinary tract infections, bloodstream infections, invasive candidiasis, and disseminated infections in immunocompromised individuals. Okay, so look at the title of this paper. Bioaccumulation of copper-2 and nickel-2 by the non-adapted and adapted growing Candida species. Where's my highlight? There it is. So, I just thought I'd hit on this. Copper and nickel are known to be the most commonly used heavy metals, and they are some of the more widespread heavy metal contaminants of the environment. So I don't like the heavy metals term by itself because there are good minerals in the heavy metal category. Zinc is one of them. However, why are all these people out on the internet trying to tell you that everybody's got copper deficiency when it's like contaminating everywhere and people are wearing clothes made of it and they're drinking out of cups made of it and they're taking supplements of it? It's in every multivitamin. They can't seem to get enough of it, and yet everybody's getting sicker. And it is well known that copper levels in the blood go up as people age. It's a psyop. One of the most ubiquitous biomass types available for bioremediation of heavy metals at lower pH values is yeast. So what they're going to do, they're going to literally take yeast and put it somewhere because it soaks up the toxic metal so much because it probably likes it. Yeast biomass is an inexpensive, readily available source of biomass. Furthermore, yeast cells retain their ability to accumulate a broad range of heavy metals to varying degrees under a wide range of external conditions. Yeast cells have been shown to accumulate heavy metals such as copper and nickel via two distinct processes. They must really like it and need it. So, ladies, if you have chronic yeast problems, you probably have a copper and a nickel problem. Let me see if there was anything else. Nope, nothing on that one. So let's hit the next one. Actually, let me open up the rest of these while I'm here. Like I said, sorry I didn't open these before I started. Okay. We'll wait for the highlights to come on. There we go. Bioremediation of heavy metals by using Aspergillus niger and Candida albicans. So, they're literally sucking toxic metals out of the environment. Bioremediation is a branch of biotechnology that employs the use of living organisms like microalgae and fungi in the removal of contaminants. Oh, sorry, I got to zoom. Joe said, "Ooh, that's not the right way." There we go. Pay attention to how much it sucks up. Like microalgae and fungi in the removal of contaminants, pollutants, and toxins from soil, water, and other environments. The study was designed to know and evaluate the efficiency of fungi to remediate two types of heavy metals, lead and cadmium, by using different concentrations. Results revealed the lowest applied dose of both tested heavy metals had the high, wait, didn't this one have nickel? Well, anyway, I thought this had nickel. Maybe I read it wrong. Maybe I was tired from going through so many studies. I thought there was nickel in it, but either way, again, black mold loves toxic metals. So does Candida. So do parasites. So do bacteria. So maybe I was wrong on that one, but it was still cadmium and lead. Oh, here we go. Nickel accumulation and nickel oxalate precipitation by black mold. Bet you haven't heard of nickel oxalate much. Some of you folks are really big on oxalates, and you're starting to realize that maybe the nickel is the problem instead of the oxalate, the dumping symptoms, the oxalate dumping symptoms. But now we have nickel oxalates. A strain of Aspergillus niger isolated from a metal-contaminated soil was able to grow in the presence of cadmium, chromium, cobalt, copper, and unusually high levels of nickel on solid and in liquid media. The fungus removed pay attention. This fungus removed more than 98% of the nickel from liquid medium after 100 hours of growth, but did not remove the other metals, as determined by inductively coupled plasma spectroscopy. Wow, it only went after the nickel. Oh, and then the crystals. The crystals were nickel oxalate dihydrate. So some of you folks who really started to work on your oxalate intake may have felt better simply because you were making less nickel oxalate. And then, as we've seen, as we saw with oxalate folks. So what did we see with oxalate folks? As oxalate folks went on the low vitamin A diet that we used, they tended to become more tolerant of oxalates, whereas people who stayed on the low oxalate diet long-term, if that's all they did was a low oxalate diet, they got more and more sensitive to lower and lower levels of oxalates. They did not get better. They got technically worse. They got less resilient. They got more sensitive. People got on the low vitamin A diet, which we still advise. We still advise a low vitamin A diet, well below the RDA. But when they got on a low vitamin A diet, their oxalate symptoms decreased, and they tended to be able to eat more oxalate in foods without having a problem. And then people thought that they were oxalate dumping, and now we have nickel, which I'm sure that when people are looking at their dumping symptoms and they understand that they went on a low nickel diet, well, a low nickel diet, here's the crazy thing when you look at the foods. A low nickel diet is automatically pretty much a low oxalate diet. And we're seeing all sorts of things improve. The crystals were nickel oxalate dihydrate. Let's keep going. Targeting bacterial nickel transport with Aspergillus A suppresses virulence-associated nickel-dependent enzymes. Wait, so what did they do? Microbial nickel homeostasis underpins the virulence of several clinical pathogens. Nickel is an essential cofactor in urease and nickel-iron hydrogenases involved in colonization and persistence. Many microbes produce metallophores. Those are things that like metals to sequester or grab onto metals necessary for their metabolism and starve competing neighboring organisms. The fungal metallophore, so made by a fungus, loves metal, Aspergillus A, AMA, shows narrow specificity for zinc, nickel, and cobalt. Nickel and cobalt come together in sensitivity all the time. And notice that they're all 2+. Remember, these things are similar in size and shape. They have different functions, but that's why these things can grab onto similar things. Ugh, get out of my way thing. Here we show that this specificity allows this metallophore, this binding thing, to block the uptake of nickel and attenuate or reduce bacterial nickel-dependent enzymes, offering a potential strategy for reducing virulence or the damage that this we're talking about a fungus. We were talking about, well, a mold. I mean, this would be made by Aspergillus. Okay. Bacterial exposure to AMA perturbs hydrogen metabolism, ureolysis, struvite crystallation, and biofilm formation. and shows efficacy in a Galleria melanella animal infection model. That was the moth larva. The inhibition of nickel-dependent enzymes. Let's pay attention here, folks. The inhibition of nickel-dependent enzymes was aided by zinc, which complexes with AMA and competes with the native nickel-04 for the uptake of nickel. Zinc inhibits nickel absorption. Zinc inhibited nickel-dependent enzymes. We keep seeing the same patterns of the things we like tend to do good things, and the things we don't like tend to do bad things. Okay? So, inhibiting nickel causes less problems. And then let's just hit on this one real quick. Did we do this one already? Oh, yeah, we did this one already. Sorry, let's go to the next one. Now we have another fungus, Aspergillus fumigatus. What can it cause? Allergic bronchopulmonary aspergillosis, aka ABPA, allergic fungal sinusitis. Like I said earlier, aspergilloma, chronic pulmonary aspergillosis, invasive pulmonary aspergillosis, disseminated aspergillosis, central nervous system aspergillosis, opportunistic infections in immunocompromised people. Or did I already do this one? I don't think I did. Let me just double check. I don't want to make you guys sit through. But again, we have another fungus. And maybe we'll just hit on the title of this one. Oh, urease of Aspergillus fumigatus is required for survival in macrophages and virulence. So I know the next one where they specifically say, oh, sorry, did I share my screen, Joe? Sorry, there it is. So let me show the title again, just so we have it on video. Urease of Aspergillus fumigatus is required. So urease, remember, nickel is required for ureases very often, and it's required for survival of this fungus. Okay. Now, I'm going to hit on this quick. Furthermore, we could show that a nickel chelator inhibits growth of this fungus on urea itself. The nickel chelator is also able to reverse the effects of urease on macrophage killing. Macrophages are white blood cells, Joe, and phagosome acidification, thereby reducing virulence in systemic and trachea infection models. So they stole nickel from this fungus, and it didn't grow, and it couldn't kill your macrophages, your big eaters. Macrophage means big eaters, and phagosome acidification. So thereby reducing virulence in systemic and trachea infection models. So that would be like all the lung things they were talking about, pulmonary, broncho, systemic, yeah. So we got that. Now we're going to get into the bacteria. Now this is where those of you who had, okay, so I'm going to apologize that I didn't figure out the nickel connection to GERD earlier. I'm sorry. I wish now it seems like it's like the research is everywhere. So I'm sorry, but I also am extremely irritated and upset for all those of you who have suffered for years and years with GERD, and none of your doctors ever said anything about nickel. You can go on Reddit and find all sorts of people saying that the nickel-free diet fixed their GERD within days. And yes, folks, if you're doing the low nickel diet, you can get GERD during it. Yes, it comes and it goes. It can happen. We've seen it in multiple people, but it's not a permanent thing. It's part of the nickel coming out of your actual stomach lining is my theory. So what does H. pylori cause? Chronic gastritis, as in stomach irritation, gastric and duodenal ulcers, so ulcers of your stomach and your intestines, stomach cancer, and gastric mucosa, that's the stomach lining, associated lymphoid tissue, aka malt lymphoma. Lymphoma and stomach cancer. Stomach cancer is, I believe it is the deadliest cancer to get. If not, it's way up there. So we would like to keep H. pylori down, and just because you don't have GERD doesn't mean you might not have a problem. So let me open up these I got to open them from the bottom up, or else they come in the wrong order. And okay. Am I a robot? No, I am human. So, didn't I highlight this one? Hello? Yeah, just got to refresh it. There we go. Nickel permease system of the H. pylori contains highly conserved G-quadruplex motifs. I know this sounds pretty complex. But anyway, H. pylori really requires nickel. Nickel, they literally say it here, nickel is a virulence determinant in H. pylori. So no nickel, H. pylori doesn't cause problems. How many places, we've seen this multiple places in the literature, and why aren't doctors the very first thing doing a low nickel diet? And is required as a cofactor for the urease and nickel iron hydrogenase enzymes. Listen to this, that are crucial for its survival in the stomach lining of humans. Crucial for its survival. Do you understand that that means 50% of the world has been said to have H. pylori in their stomach? So can we then say that 50% of the world is at minimum nickel toxic? They have enough nickel in them to grow bacteria that shouldn't be there. Do you see how big this problem is now? Crucial for its survival. So why aren't doctors reading this and going, well, gosh, why don't we just starve it? Because doctors don't want to talk to you about diet. They'd rather fill you full of proton pump inhibitors, which literally send you to the grave earlier. Proton pump inhibitors literally increase your diseases a ton. It's all out there. But nobody ever told you about nickel. Or they said, oh, do the alginate, the sodium alginate, like over-the-counter stuff for your GERD and your ulcers. Because it makes an alginate raft at the top of your stomach. It doesn't do that. It soaks up the nickel that's causing you the problem. Oh, and then like, oh, now we know. So, right, they'll talk about, oh, you can do apple cider vinegar for your GERD. I want you to understand what they're doing now. So, the H. pylori and other probably bacteria that are in your stomach are literally using their urease to feed themselves nitrogen and to make ammonia, which is alkaline, to keep your stomach alkaline so they can live, and they need nickel to do this. Okay? So it's too alkaline in there. So you put down acetic acid, which is vinegar. And maybe it makes it inhospitable for them a little bit more, but does the vinegar wash away and go away after a bit? Yeah, so you didn't solve the problem. You just changed the environment for a second. The H. pylori didn't like it, didn't thrive through that, and then they come back because you have plenty of nickel in your stomach. So, okay, so I don't know how much we're going to spend on H. pylori. I mean, H. pylori needs nickel. Literally, the best thing you can ever do for anybody with reflux is tell them, well, be careful of just jumping them onto the low nickel diet, but they might start with some sodium or potassium alginate, maybe some pectin, get things soaking up, do the Pecticlear for a month, and then get into the low nickel diet. Because if you just put somebody on a low nickel diet, at the start, they may not feel good. And if you haven't seen that episode 2 or 3 episodes ago, you should watch it. Characterization in H. pylori of a nickel transporter essential for colonization. Nickel transporter essential for colonization that was acquired during evolution by gastric Helicobacter species. Well, we're not going to talk about evolution. Oh, sorry, I got to zoom. Thanks, Joe. Metal acquisition is crucial for all cells. Yes, and for the virulence of many bacterial pathogens. Let's see if there's anything else in here that's new that I haven't been over. While I'm getting here, there's multiple transporters. It's really, really important for H. pylori. H. pylori is a bacterium that persistently colonizes the stomach of half of the human population worldwide. To resist gastric acidity and proliferate in the stomach, H. pylori possesses an urease. This enzyme contains a nickel metallocenter at its active site. Thus, the capacity of H. pylori to infect its host relies on important nickel supply despite its scarcity in the human body. Well, it only needs enough, right? So they're saying here the acquisition of nickel transporters by gastric H. pylori was a key event for the emergence of one of the most successful bacterial pathogens, H. pylori. The most successful one requires nickel. Gosh, so imagine what would happen to all the less successful ones if we actually fixed the nickel problem. Okay, so that's H. pylori. Oh, Staph. Let's get into Staph. So Staph aureus, you may have heard of, you remember how we went over drug-resistant earlier? What's the famous drug-resistant bacterial infection? MRSA, right? Methicillin-resistant Staphylococcus aureus, MRSA. They just can't seem to get it under control. Staph aureus, just the regular kind, can be associated with skin and soft tissue infections, pneumonia, bacteremia, that's bacteria in your blood, and sepsis, endocarditis, so that's the inflammation of the heart lining, osteomyelitis, infection of the bone, septic arthritis, toxic shock syndrome, staphylococcal scalded skin syndrome, and food poisoning. So when we talk about nickel toxicity, people go, what symptoms does it cause? Well, it can cause anything anywhere. Okay, there's trends, there's tendencies. But let's get into the let me do a new one here. And then we will open this one up. Come on, PubMed. A nickel ABC transporter of Staphylococcus aureus is involved in urinary tract infection. Ladies had any urinary tract infection issues? They're probably all nickel related, just so you know, because we'll see multiple urinary tract infection bacteria in this. So, I don't know that I'm going to spend tons of time on this. There are multiple nickel transporters in Staph. Oh, yeah, here we go. The opportunist pathogen, Staph aureus, encodes 4 putative OPPs and 1 Orphean substrate binding protein, OPP5A. The 2 complex and the 5A are involved in nickel uptake and then renamed them Nic BCDE and Nic A respectively. Staph aureus carries also a high affinity nickel transporter, Nix A, belonging to the nickel cobalt, I'm guessing that's nickel cobalt, family of secondary transporters. But it's got lots of stuff for nickel. Inactivation of the Nic genes affected bacterial colonization of mouse urinary tract, as well as the 50% effective dose levels compared with the parental and Nix A strains. So there was, when they inhibited the Nic genes, I'm guessing they didn't have as many problems because that's in the bacteria and it couldn't get its nickel, so it couldn't colonize. Oh yeah, finally, complementation of the Nic mutations restored bacterial colonization, so they completely need nickel to colonize. Together, our results suggest a role for the Nic system in urinary tract infection by Staph aureus, probably due to the urease-mediated pH increase of the urine. Right, pH is an issue in urinary tract infections, is it not? People drinking baking soda or other things, or they do other things to change their pH when they're saying it's the urease down there that is really causing the problem. So now we're going to get into Pseudomonas aeruginosa. What is this? Hospital-acquired pneumonia, ventilator-associated pneumonia, urinary tract infections, again, bloodstream infections and sepsis, wound and burn infections, chronic lung infections and cystic fibrosis, otitis externa, that's ear infections, folks, keratitis, and folliculitis. Again, do you see how the list of these things just keeps getting longer and longer? Let's go to the new window, and then we will start opening these up. Okay. So pretty straightforward here. Intracellular nickel accumulation by Pseudomonas aeruginosa and its chemical nature. Why is it accumulating nickel? Because it likes it. So let's go to the next one. Oh, now I got motorcycle. Oh my goodness. I got to make this smaller. There we go. Wow, thanks PubMed. You're really preventing lots of crime, I guess. It's a role of modifying factors. So we got more. Pay attention here. A major nickel transport system was competitively inhibited by magnesium. We like that. Zinc, we like that. And then we get into other things, cadmium and cobalt, which are not good. Notice they're all +2s. So what can you do? So this is okay. You understand when I tell you guys, sometimes people will be like, but the zinc was listed in there with the heavy metals, and zinc is a heavy metal, and why don't we just avoid all heavy metals? And I'm like, no. Your body is going to put things into the slots. You understand? It has a certain number of slots. And if a metal, mineral, good mineral, bad mineral that fits in that slot comes along, the body's going to put it there if it fits. Kind of like if you just had a bunch of unrented apartments and you're not doing so hot income wise, and you have people come who maybe you don't want them to live in the apartments, you know their problems, but you got to pay the rent for the apartment complex, so you put them in the slots. So you're either going to put good people in those slots or you're going to put bad people in the slots, but the slots are going to be filled. I would much rather have magnesium and zinc in those slots than nickel or cadmium or cobalt. Do you understand? This is really, really important. So we don't just avoid +2s, divalent cations, because, oh my gosh, nickel's in there and cobalt's in there and cadmium's in there and all and manganese and copper. No, we put in the good guys to fill the slots and to kick out the bad guys. Oh goodness. Here, let's see. Let's do the bridges. Let's play this game. I'll remember to did I miss any? Oh no. No pressure. What if I do it wrong? I'm so embarrassed. So I thought this was interesting, right? So we've talked a lot about modified citrus pectin and apple pectin and Pecticlear, which is sodium alginate, but I thought I came across this. Improve the pulmonary bacterial clearance of Pseudomonas aeruginosa lung infection in mice by modulating intestinal microbiota and immunity. I don't think I hid a pectin. It fed their gut and it bound to, I don't know, toxins like nickel. The results suggest that pectin basically may have beneficial effects by limiting the number and severity of pulmonary exacerbations in patients chronically infected with Pseudomonas aeruginosa, such as individuals with cystic fibrosis. Oh, that makes me want to look up cystic fibrosis and nickel. Anyway, moving on. E. coli. Hey, there's another urinary tract infection one. So E. coli, UTIs, gastroenteritis, neonatal meningitis, bloodstream infections, and sepsis. We keep seeing sepsis here for all these nickel-loving pathogens, intra-abdominal infections, and pneumonia. Well, are you seeing how many of these there are that you've heard of, right? Did I do these in the wrong order? I don't know. Maybe I did. Here we go. So I don't have to spend a lot of time on these. You guys understand nickel-containing hydrogenase isoenzymes from an anaerobically grown E. coli. I made it simple. Both hydrogenase isoenzymes contain nickel. So what happens if you starve them of nickel? What happens if you starve E. coli of nickel? Hold on, let me see. Oh, I highlighted that first one 3 times. Let me see if we can't get this to work. Oh, well. What did we start with? Invasive gram-negative bacteria. Okay. So I wanted to hit on the E. coli here. Virulence associated, as in it makes them dangerous, metal ion chelators to combat host-mediated metal deficiencies. Like your body is trying to keep things away from these bacteria. E. coli, Klebsiella, and Yersinia pestis, as in the plague. Isolates encoding the Yersinia high pathogenicity island secrete Yersinia-bactin, YBT, a metallophore as it loves metals, originally shown to chelate iron ions during infection. So it grabbed onto iron ions. So the pathogens wanted more iron. Again, this is why we don't want an excess of iron in our system. However, our recent demonstration that YBT also scavenges copper ions. That's weird. Copper showing up again during infection led us to question whether it might be capable of retrieving other metals as well. Here we find that uropathogenic E. coli, as in urinary tract disease, also use YBT to bind extracellular nickel ions. We find that E. coli and Klebsiella direct the nickel liberated from this pathway to intracellular nickel enzymes. They use it to function. So, those of you out there with GERD and urinary tract infections, you should know that the fix is here. Salmonella. Salmonella enterica serovar typhimurium. This is mostly when you talk about salmonella, this is what you're talking about. So look at what it causes: gastroenteritis, salmonellosis, foodborne diarrhea, bacteremia, focal invasive infections, systemic disease resembling typhoid fever in, drumroll, the immunocompromised. Do I have to do the, oh, I don't have to do it. Great. Let me see. Did I get anything in here? Let's see. There it is. I don't know. That didn't show up. Initially, cobalt's in there. The role of the TON-B dependent transport has since been expanded to the transport of various other substances such as nickel, carbohydrates, cobalt, and copper. There they are again. They just keep showing up. As in other gram-negative bacteria, the TON-B XBD system of Salmonella typhimurium could play a crucial role in fulfilling the increased demand for the delivery of substrates such as iron siderophores, vitamin B12, nickel complexes, and carbohydrates in a nutrient-limited environment. What if you just starved it? Now, these were interesting. Let me get into the viruses, the virus section. Okay. So these were very interesting. They were done by the same authors, these two papers, several years apart. A common viral infection can change nickel target organ distribution. So what I'm just going to say about this is, do I believe that there are little non-moving, non-functional proteins called viruses moving around causing your body to do this? No, there's toxins. If you believe in viruses, I mean, you're not ready for this yet. If you still believe that viruses are the cause of disease, they're not. It is a boogeyman created to make you afraid of things that you can never see. And if you believe they're CGI pictures of them, I guess, I mean, go ahead. Okay, so the autoradiographic distribution of the toxic heavy metal nickel was studied at 4 and 7 days post-Coxsackie virus B3 infection in bowel mice. Okay. So they injected them with some toxic brew, that they called Coxsackie virus. Okay. As you know, with the shots, there's never one ingredient in it. It's tons of things, including lots of things that are known to not be great for people. They show that the site of 63 nickel accumulation is greatly changed during this toxin infusion. This newly discovered distribution was mainly visible as a greatly increased accumulation in the pancreas, gosh, diabetes, and the wall of the ventricular myocardium, gosh, heart disease. Healthy animals showed almost no 63 nickel accumulation in these tissues. They injected them with toxins and the nickel moved around. Okay. Same authors. Changed distribution and immune effects of nickel augment viral-induced inflammatory heart lesions in mice. This was 92 and 94. Did I highlight that one? I think I did. So they used a toxic soup injected into mice to investigate the immunotoxic effects of a 10-week low-dose administration of nickel chloride. 10 weeks low dose prior to infection. The dose did not influence the rate of death, the risk of death. 7 days after the inoculation, impulse counting of these organs showed the infection-induced increase of nickel to be 5 times higher in the pancreas, 2.2 times higher in the lungs, and 1.3 times higher in the heart. Inflammatory and necrotic, as in tissue death, lesions in the ventricular myocardium 7 days after the inoculation covered 3.31% of the tissue section area in infected control mice. So they just gave the toxic soup to the control mice. They didn't give them the nickel. This damage was increased by 43% to 4.744% of the tissue section area in nickel-treated mice. 43% more heart damage in the nickel-treated mice. Toxins are synergistic. So we got that. So that's an interesting thing. Now let's go into the coof. And that is what I will call it. Oh, I went backwards. Oh, well. Okay. So impact of the coof on temporal trends, as in time-based trends and health risks of urinary metal concentrations among residents of Guangzhou. We evaluated the temporal trends over time of urinary metal ions among 1,962 residents of Guangzhou, China from 2018 to 2022. The total metal ion concentrations in the urine of the population did not change significantly between 2018 and 2019. Interesting. With the onset of the coof pandemic in 2020, urinary total metal ion concentrations began to decline dramatically, reaching their lowest level in 2021. A rebound in concentrations was observed in 2022, which returned to the initial levels observed in 2018. Now, isn't that interesting? The urine went down. How could that happen systemically among 1,900 people? What was actually going on? Did they suddenly have their nickel pulled away from them and then they started going into the low nickel detox dumping? I don't know. Urine chromium and cadmium concentrations peaked in 2020, while urinary lead levels were the highest in 2021. Wait. So urinary total metal ion concentrations went down. Okay. But chromium and cadmium peaked. And urinary lead levels were the highest in 2021. And urinary nickel levels were the highest in 2022. So first they tell you that they all decline dramatically, and then they go up. But in the same time period. I don't know. Males consistently displayed higher urinary concentrations of lead and arsenic throughout each year of the study. Men detox faster and men are out working with this stuff more. Further, pay attention here, folks. When I'm like the kids, we're passing it down to the kids. Furthermore, minors consistently had higher urinary nickel than minors. The Monte Carlo simulations indicate that the whole population exhibits a high non-carcinogenic risk from arsenic exposure and significant carcinogenic risks associated with exposure to nickel, arsenic, chromium, and cadmium. Okay, well, let's get into the other papers. Why isn't this showing my highlights? Oh my gosh. Well, I thought it had the highlights on it. Maybe this is one of the ones I missed. Elemental concentrations in biological samples of COOF disease and other pulmonary disease patients. So they were looking at zinc, iron, copper, cadmium, nickel in human biological samples such as scalp hair, serum, saliva, blood, nasal fluid, and sputum of smoking and non-smoking male COOF patients from Pakistan. Let's just find nickel in there. The found average of essential elements, zinc, iron, and copper in biological specimens of smoker and non-smoker male COOF, tuberculosis, and pneumonia patients was found to be lower. Wow, they found lower zinc. Shocking. Whilst cadmium and nickel were found to be higher when compared with samples from reference. What does zinc help detox? Cadmium and nickel. Wow, they found lower zinc, higher cadmium, and higher nickel. Zinc also helps you fix your iron levels too. So anyway, our findings also suggest that higher cadmium and nickel concentrations are linked to cigarette smoking, which could lead to COOF and other lung-infected disease recurrences. Folks, breathing in nickel seems to be a big issue, so you need to get a HEPA filter of some sort for your house, at least HEPA. If you decide to go beyond that, that's fine. When I type up the big PDF of all this stuff, I don't know if we're going to call it an ebook, but when I type it all up, we will have some cheap plans for a good, HEPA level filter that you can make very inexpensively as opposed to the big fancy filters. You got it. You want to fix your air. Next week. The tonsil stuff is insane. If you had tonsillitis, if you had to have your tonsils and your adenoids removed, you're nickel toxic. Just wait until you see the concentration of nickel in the tonsils compared to the other organs. Tonsils were by far the highest. How would they be exposed? Well, eating and breathing. So this is one where they're trying to cover it up. Urinary cadmium concentration is associated with the severity and clinical outcomes of the COOF, a bi-center observational cohort study. So they start with that, just cadmium. Then they go, cadmium and nickel exposure can cause oxidative stress, induce inflammation, inhibit immune function, and therefore has significant impacts on the pathogenesis and severity of many diseases. Wow, did they just include nickel in many diseases? Interesting. The severe COOF patients were older, had significantly more comorbidities. They were sicker in general and significantly higher neutrophil to lymphocyte ratio, C-reactive protein marker of inflammation, and interleukin-6 than the non-severe COOF patients. Blood and urine cadmium and urine nickel concentrations were significantly higher in the severe COOF patients than in the non-severe COOF patients. Is it a virus? Or is it just toxicity? Oh, Hep C. Here's another fun one. I think I have... Let's see. Okay. Here, I'll zoom, Joe, before you ask me. Determination of nickel and zinc concentrations in the blood serum of hepatitis C patients using atomic absorption spectroscopy, right? Spectroscopy, yes. Just wanted to say the word right. Well, let's see. I see the zinc right here. In contrast, serum zinc concentrations were markedly reduced in Hep C patients, relative to controls, suggesting a deficiency that may weaken antioxidant defenses and compromise immune function. These findings were supported by graphical comparisons that confirm my entire hepatitis episode. Folks, if you think Hep C is like an infection, it's toxicity. The observed imbalance in nickel and zinc metabolism. The imbalance in metabolism. Hepatitis C patients exhibited a higher mean serum nickel concentration compared with controls. Now, I want you to look at those numbers. I know you're going to look at those numbers and be like, wait, Hep C patients 2.41 compared with controls 3.25. That's not right. It's a typo. It's literally a typo. I'm going to go show you because I saw that and I was like, wait. We go to the actual paper. So here's the graph of the zinc. Oh, sorry, I'm not looking. There we are. Now we're looking at it. Here's a graph of the zinc, right? Healthy controls are up in the 80s. Hep C is down in the 60s. Gosh, zinc deficiency showing up again. Look at this graph of the nickel. Healthy controls, 1.7-ish. Hep C patients, 3.5. Double. Twice as much. Does this mean that they were actually high? No. It means that they were twice as high as the healthy controls. There it is. So, Hep C. Okay, now let's get into HIV. Here's the paper: evaluation of arsenic, cadmium, lead, nickel, and zinc in biological samples, scalp hair, blood, and urine of tuberculosis and diarrhea male. That's very mean. Is that a type of male? A diarrhea male? And diarrhea male human immunodeficiency virus patients. Hopefully you figured out that this is a made-up condition, mostly through people who are poisoning themselves with recreational drugs and poppers and crack and other things of that nature. There's a great article by Anthony Colpo, C-O-L-P-O, if you wanted to look up HIV and AIDS apart. It's an amazing article. Okay, the results indicated significantly higher levels of arsenic, cadmium, nickel, and lead in the biological samples, all of them of male HIV patients compared with control subjects. Wow, they're just more toxic. It was observed that the high levels of these toxic elements may be predictors for secondary infections in HIV-1 patients. There was a significant increase in the mean values of arsenic, cadmium, nickel, and lead in whole blood, scalp hair, and urine samples of 3 groups of AIDS patients as compared to controlled healthy male group. So it looks like immunocompromised, again, is just toxicity. And why does nickel keep showing up in these papers and yet no one is talking about it? Are you seeing the pattern? Like, people talk about cadmium and arsenic and lead, and these are all very bad, but nobody's talking about nickel. Joe, sorry if maybe I was wrong on the anthonycolpo.com website. I will, maybe I'll look it up here real quick. Oh, this is what oh boy, now we're getting into it. Cavities, folks. Cavities. So what are we going to correlate here? Because the dental industry will not do this research. So Streptococcus mutans is said to be the bacteria that causes cavities. The main one. So we're gonna start correlating things. So let me get through this. Let me open up all these links. And so do I see there's some of these things out there that say they kill strep mutans? Maybe they do. Are they fixing the root cause of it? No, not at all. They're killing the bacteria that feeds on the nickel. Does that make sense? And so if you kill that bacteria, it's not virulent anymore. But you have not killed the food supply. That makes sense. So here's what I wanted to go over. 5, if you have them, is braces, orthodontics, metal orthodontics, and retainers. Okay. So here's what I'm going to do. So they literally put stainless steel in your mouth. They put nickel, titanium, nitinol. They put in like the braces are stainless steel. Like they're putting nickel in your mouth. If you had metal braces or a metal wire on your retainers, you have nickel toxicity. If you got a lot more cavities during that time, the nickel caused it. I mean, you may have been terrible about brushing your teeth, but most people who are terrible about brushing their teeth while they have braces were terrible about brushing their teeth before they had braces. It's kind of a habit, right? So 2024, the distribution of initial caries, that's cavities, lesions, in relation to fixed orthodontic therapy, that's braces, a systematic review and meta-analysis. Look at where they're located. Initial caries lesions, as in new cavities, adjacent, right next to orthodontic brackets, are the most common side effect of orthodontic treatment with fixed appliances. The reported prevalence is uncertain and varies considerably across studies from 27% to 97%. 97%. I'm amazed I didn't get cavities through my orthodontics. But I do think it led to other health issues later. That is why I'm now doing what I do. Was there anything else in here? Oh, the prevalence and incidence rates of initial, or what do they call them? Initial caries lesions in subjects undergoing orthodontic treatment are quite high and raise some concerns in terms of risk assessment of orthodontic treatment. ICLs represent an alarming challenge for both patients and professionals. Alarming, quite high, raise concerns. You know what I'm pretty sure orthodontists do to their patients who get cavities during their orthodontic treatment? They blame the patient and they say, you're just not brushing hard enough. You're not brushing often enough. You're not doing this. You're not doing this. It's like the personal trainer that you're in this much of a calorie deficit and you're not losing weight, or you're literally gaining weight. I've seen it before and I believe the people. They're toxic. And it's shutting down their thyroid. Oh, wait, does nickel shut down thyroids? Yes, it does. So first, we're just correlating braces with cavities, okay? Because no one's doing the study on the amount of nickel in the saliva causing cavities on real people's teeth. Nobody's doing that research. Why would they not want to do this research? Do you understand that the orthodontic industry would hate this research? They're like, no, we don't cause cavities. We don't cause cavities. That's not our fault. It's definitely not the stainless steel. Like Kelsey and I went and we met a biological dentist in her area, and we were talking to him about something, nickel, and he goes, oh, we will put no metal in people's mouths. No metal in people's mouths is what he said. We don't do any metal in people's mouths. And I was like, wow, awesome. Like we're in a good place. So if you have metal in your mouth, I'm going to tell you, like, people be like, but what about my gold filling? What about my gold crown? What about this biological dentist, no metals in the mouth. Dr. Kamastra, when we had him on, he was talking about the different metals when you have different types of metals in the mouth, creating a galvanic reaction, and they would actually corrode faster because you had different metals in the mouth. I just found out, thank God, my son has 2 visits left with his orthodontist, and the second visit he gets off the braces. So happy. So happy. Okay. And yeah, it's my fault. Yeah, I take responsibility for it. Why is this not doing? Oh, it's not. Okay, here we are. I want to go to the highlight, please. There we are. So they looked at 100 orthodontic patients aged 12 to 29 years with an average age of how many fillings they already had. They had high and low groups in terms of the number of filling stuff. Patients with a higher numbers of fillings before orthodontic treatment ran a higher risk of developing cavities. They had significantly higher numbers of mutans, streptococci, and lactobacilli, and had less chance of avoiding new cavities according to the karyogram. So let's use logic here. If they already had a lot of cavities, does it make sense they're already more nickel toxic? Yeah, if nickel causes cavities, they're already more nickel toxic. Oh, let's add braces on top of it and then wonder why they got even more cavities. Gosh, the cavity bacteria literally literally eats nickel. You're going to see this in the following studies. Okay. And wait, what is this lactobacillus? What's that study I was showing you where a lactobacillus literally helped people on a low nickel diet to improve even more? Wait until you find out that lactobacillus soak up nickel. They don't use it to attack you. They just hold on to it and then you poop them out. What if all the fermented food stuff is just lactobacillus soaking up nickel so you can poop it out? What if we're just like deconstructing all of the magical health myths out there into toxicity and deficiency? Okay. Nickel release and the viability of strep mutans corresponding to low risk of dental caries and artificial saliva containing orthodontic appliances. In vitro study. So this was not in the mouth. So they had simulated fixed orthodontic appliances, so braces, composed of copper, nickel, titanium. Well, that sounds great. Copper and nickel, titanium, or stainless steel. Nickel in all of them, right? Day 7. Same levels of strep mutans cultures were inoculated into the artificial saliva without orthodontic appliances. So that's their control, right? Nickel release was detected by inductively coupled plasma mass spectrometry. The arch wire surface, the wire, right, was analyzed by atomic force microscopy and scanning electron microscopy. They're looking to see how rough it is. Streptococcus mutans increased nickel release only in orthodontic appliances with stainless steel arch wires. Well, there would be. Those brackets all are stainless steel as far as I know. Streptococcus mutans increase the surface roughness of only the stainless steel arch wires. It's increasing the roughness. Do you understand that it was smooth and now it's rough, which means that strep mutans is literally eating the stainless steel. It's literally eating away the stainless steel. Wow. What was that we said? More braces results in more cavities. Streptococcus mutans literally eats the braces, feeds on the nickel, and then you get more cavities. Okay, let's keep going. What happens when they coated the wire? Evaluation of titanium dioxide coating on surface roughness of nickel titanium arch wires, there's that nickel again, and its influence on strep mutans adhesion and enamel mineralization, a prospective clinical study. So they coated one of the wires, right? They had a titanium dioxide coating, probably a white looking coating on one of the wires, the coated one, and then they had an uncoated wire that was just the stainless steel or the nickel titanium, whatever they were using. Yeah, nickel titanium. There it is. Streptococcus mutans adhesion was more in uncoated arch wires. The titanium dioxide got in the way. But they both, after 1 month, both of them had a rougher surface. Streptococcus mutans adhesion was lesser on the coated wires. So what I'm getting at is the strep mutans really likes the stainless steel. Let's get into this one. Temporal, as in time-based alloys used in orthodontics in relation to surface characteristics, was analyzed. Now, I'm just going to take an aside here. Folks, the more nickel you have in your body, the more nickel you're going to have in your saliva and in your bile that you might reflux into your mouth. You're basically just going to have, so it's not just braces. The braces are the obvious thing to correlate. the amount of nickel in the marinating saliva of your teeth all day is the big determinant. It's just putting stainless steel in your mouth is like just dumping a hot load of nickel crap in your mouth. That's what it is. Okay, so what did they look at? Strep mutans, Streptoralis, Veillonella parvula, and Aggregatibacter actinomycetum comitans. How'd I do? Anyway, we're incubated for 4 hours with nickel, titanium, and stainless steel wires. The surface roughness and free energy of the alloys, as well as the hydrophobicity, that's the not liking water, as in like more like fat love. Hydrophobicity is generally thought to be lipophilic of the alloys and bacteria was assessed. Nickel titanium had a higher surface free energy and rougher and more hydrophilic surfaces than stainless steel. So now we get stainless steel was lower than the nickel titanium. It just wants the nickel. The hydrophobic properties of the bacteria decrease in the following order. Bacterial adhesion generally increased over time, though this pattern was influenced by the type of alloy and the bacteria present. So bacterial adhesion increased over time, right? The longer there are some papers out there that they say, oh, well, the nickel comes off the most in the beginning, like 3 days is the highest, and then 7 days, and then 10 days. And then they're like, but it's stabilized. The amount of nickel coming off the orthodontic appliance is stabilized. They're like acting like that's a good thing. No, it's saying that now, okay, so maybe you put out 10 units the first day of nickel into your mouth. And then it goes down to 7, and then it goes down to 5, and then it goes down to 3. And every day you have 3 units of nickel coming out in your mouth. That doesn't mean it stopped. It means it's stabilized. So now you have a 3. Okay. Again, just more on this. Strep mutans adhesion on nickel titanium and copper nickel nitinol. That's our nickel titanium arch wires. Is there anything else interesting in this? No, it just same stuff. And I wanted to go over this one because. So this has a couple of implications. Brewed Robusta coffee increases nickel ion release from dental alloys, an in vitro study. So what am I going to use this to say? Very simply, the concentration of nickel increased in saliva of low pH due to brewed coffee. Dentists should be cautious when using instructions for patients with a history of allergies, especially for dietary diets with low acidity. Okay, this means a couple of things. First, coffee is acidic. What causes nickel to leach? Acidity. That's one of the main things. So coffee is going to leach more nickel from whatever it touches. That's what I'm generalizing here, right? So if you go to, let's say you go to a coffee shop or you make coffee at home and you make it in stainless steel, the acidity of the coffee is literally leaching nickel from the stainless steel. It doesn't matter whether the stainless steel is braces or whether it's your container for your cold brew or whatever. The acidity, so even cold brew, right? It's still acidic. It's less acidic, still acidic. So if you are keeping your coffee or your coffee shop is keeping your coffee in stainless steel stuff, you're getting a dose of nickel from that. And then the coffee shops might have it in there for a long time. So I just wanted to bring this up. I didn't look up coffee and cavities, which would be interesting. But anyway, so we got that. But I thought that was a fun part. Oh, let's just look up these. Let's do nickel as a vaccine adjuvant. Imagine that they'd use it for that. Here we go, Joe. So this is the adjuvant, which basically they say boosts the potency and efficacy of the shots. So conjugation or binding to nickel chelating nanolipoprotein particles. Wait, don't I remember something about the shots? Lipid nanoparticles? increases the potency and efficacy of subunit vaccines to prevent West Nile encephalitis, which was always such a big deal, right? Here we describe a simple method for improving the potency and efficacy, as in your immune system freaks out more when they put it in you, of a recombinant subunit antigen by its immobilization on nickel chelating nanolipoprotein particles. These results have broad implications in vaccine development and optimization, as nickel nanolipoprotein particles technology is well suited to many types of vaccines, providing a universal platform for enhancing the potency and efficacy of recombinant subunit immunogens. There's one. Wait, what's this? Lipid nanoparticles with accessible nickel as a vaccine delivery system for single and multiple histidine tagged HIV antigens. So yeah, they're basic, so we got an HIV shot. We'll just read this last one. In conclusion, nickel nanoparticles are an efficient delivery system for HIV vaccines, including both single antigen delivery and multiple antigen co-delivery. So they'll give you a bunch of stuff at once. Now let's go into the last part. So this is the last part. Wow, it's only like 11:50. Man, I cruised. Oh, wait, let me do it in order. Okay. Here's the title. Biosorption, as in bio poop. And they saw that it grabbed onto and it held onto a bunch of nickel. But do we hear about lactobacillus infections? No, we think of these as good bacteria. Wow, is it kind of like parasites accumulating toxic metals to protect us from them, and they feed on them? Now we have lactobacillus soaking up a bunch of nickel that we literally poop out. What's the most popular type of probiotic out there? Lactobacillus. What is it helping with? Nickel. Nickel is a heavy metal that has a variety of negative impacts on living organisms and causes different health disorders. Probiotic bacteria have been recently utilized for nickel detoxification through bioremediation strategies. Wow, it's strong enough. They grab onto enough nickel that they can use them out in the wild. We inspected that the role of probiotic lactic acid bacteria in reducing nickel toxicity has been investigated using two biological methods, including biosorption and bioaccumulation. 17 strains of nickel-resistant probiotic lactic acid bacteria isolated from the human microbiome were selected out of 88 strains by 3 different screening stages, comprising disc diffusion, MIC, and that would be minimum inhibitory concentration, and biosorption/bioaccumulation tests culminated in 4 of the most powerful strains in reducing nickel from their culture medium. I have a product idea now. They were Lactobacillus brevis 205, Lactobacillus mucosae 226, Lactobacillus casei 375, and Bifidobacterium, I believe that's Bifidobacterium infantis 1001, with the mean nickel biosorption rate. Look at this, with the average nickel biosorption rate of 82%, 66%, 70%, and 74% respectively. The bioaccumulation test resulted in an approximate rate of accumulated nickel inside the strain cells. L. casei, L. brevis, and L. mucosae had the best rate of about 43% nickel accumulation, followed by Bifidobacterium infantis with a 42% bioaccumulation rate. This study supports that the theory of applying probiotic lactic acid bacteria to food and water detoxification could be a safe, bio-friendly alternative for gut remediation. Sorry, I didn't switch, Joe. Probiotic supplementation in systemic nickel allergy syndrome patients. Study of its effects on lactic acid bacteria population and on clinical symptoms. So we have a lactobacillus here, this specific one, which is sold as BioGaia gastrus, Gastrus. You can find it on Amazon if you want. But what did they find? They had a shift in the fecal community with an increase in biodiversity in patients supplemented with probiotic Lactobacillus reuteri strain. That specific one. You got to understand, you can't just be like, you know, if you're like, somebody says, well, you need to get a guy with the last name of Smith because he's real smart. Go find a guy with the last name of Smith. You can't just do that, right? Because there's tons of Smiths out there and they're not all smart. So you can't just like do Lactobacillus reuteri and think that it's all the same. You understand? There's families. And even within a family, there's people you trust and there's people you don't. So it doesn't just mean when you see probiotics and they're very specific, if you want that effect, you have to get that probiotic. Okay? So in addition, GI reactions, gastrointestinal reactions, such as symptoms related to meals and type of stools, significantly improved only in patients treated with Lactobacillus reuteri, while severity and frequency of cutaneous skin symptoms, urticaria, that's a rash, itch, and eczema, and recurrent abdominal pain, as well as VAS scores, I forget what that stands for, statistically decreased in both groups. So what they're saying, the low nickel diet helped the skin symptoms and the gut symptoms. Hey, where does nickel store the most first? The skin and the gut. Okay, so low nickel diet helped both of those, but the gut symptoms improved the most in the people who did the low nickel diet and took this probiotic. Okay. Am I saying you got to go buy it? No. Could it help? Especially if you have a lot of gut related symptoms from nickel? Yeah. So now we know what this was doing. They don't mention nickel in here other than they're doing a low nickel diet. But what do we know the lactobacillus is probably doing? Combined with oral administration of selective probiotics on patients with systemic nickel allergy syndrome and gut dysbiosis. So let me go find. Oh, Joe it was the visual analog scale. So yeah, they have people point to a score, their visual analog score. So what I wanted to find was the fermentative dysbiosis group represented the largest group, followed by the mixed dysbiosis group, while only 2 patients had putrefactive dysbiosis. So what I want to find, hold on, I want to find the fermentative dysbiosis people got the lactobacillus. The larger group was the one with the fermentative dysbiosis. Two-thirds of the people in this study with nickel sensitivity, followed by the mixed dysbiosis group, while only 2 patients had putrefactive dysbiosis. So they had no research on bifido. I didn't see this before. The 2 patients with putrefactive dysbiosis agreed to follow only the low nickel diet. So they were going to give the putrefactive dysbiosis folks were going to get bifido. But it appears now that only the 2 with the putrefactive wouldn't even take the probiotic. Brilliant. Okay. So, I wanted to show you. So the larger group was the one with fermentative dysbiosis, followed by the mixed dysbiosis group. So these guys got bifidobacteria and lactobacillus. The putrefactive would have gotten bifido. So fermentative got lactobacillus only, a mixture of lactobacillus. Mixed dysbiosis got bifido and lactobacillus. And the putrefactive were supposed to get bifido, but apparently they didn't do it. So what I want to find is, if I can find it, is the graph of improvements. So pre-treatment, mostly fermentative, some mixed and some putrefactive. Post-treatment, after they gave the lactobacillus people lactobacillus, or the fermentative they gave. Let me find the other one. What they're just going to show is it's going to show that the people who took the probiotics did better. Yeah, here we go. So this is pre and post-treatment percentage distribution of eubiosis as in a good gut biome or dysbiosis condition stratified for type of treatment. Okay. Pre-treatment, All of the nickel sensitive people had a dysbiosis of some sort. Post-treatment with only diet. 58% of them still were dysbiotic, but 41% of them fixed their gut bacteria. Okay, so nickel by itself messes up your gut biome. So if you want to start working on your gut biome and your leaky gut, start with nickel. But be careful. Make sure you prep, which is in the other video. And then the post-treatment with diet plus probiotics, well, instead of just 41% of them improving, they got 72% of them improved to a eubiosis, a good gut biome state. So, folks, I have to revise my probiotic articles because way too many people think that they are putrefactive and that they need bifido. This study showed, remember, it showed that the putrefactive still came into normal gut bacteria just from the diet. I want to tell you, one of the things that we sell that could help with this is sun fiber. Sun fiber feeds lactobacillus and it feeds bifidobacteria. So regardless of whether you have a fermentative or a putrefactive or a mixed, it's going to feed the bacteria to help them get back to normal. And then if you start reducing the nickel in your diet, then your gut biome is going to start fixing itself, even if you only did diet. Okay? So that was I think that's everything for today. Whew. But yeah, you guys, the link is in the chat, and Joe will put this as the pinned comment, and maybe I'll remember to put it in the maybe I'll remember to put it in the box. Are very much related to nickel. Let me see if I can find, where is oh, Joe wants the link. I already gave you the link, Joe. I'm trying to find the oh wait, I'm in the wrong. I need to get back to the studio. And I have too many windows open. Hold on, let me find the tab that takes me back there. Oh man. I don't think I've ever had this many windows full of tabs open. So Joe's probably telling me some secret right now in the messages, and I'm just going to find it. Come on. Joe, you keep hitting it. I'm still going to look. There we go. Okay. I got it. I'm going to do it the slow way, Joe. So, okay. Since I finished early, I'm going to go through the chat. So, hello, Beth. Nice to have you here. If you guys don't know, Beth is now in the Love Your Liver program. She's doing a free weekly group called Deprogramming Your Health. And I'm recommending it to people. I'm actually going to have a personal session with Beth very soon where I'm going to work on something that's been nagging at me. So I do, if you guys don't know, I highly recommend Beth, and I use her myself. So she's got a free group in the Love Your Liver program, which might be worth the cost of joining all by itself. And then, then if you want to work with her privately, then you can too. So the link to the doc is in the chat. And then hello, Kelsey. Nice to see you here. I don't know if she's still here, but we'll see. Let's see. Okay, let's see. Valzim says germ theory is false. Yeah, well, okay. I want to temper that, right? Because there's the gut biome. So if we say, like, it depends on when people talk about germ theory. Like some people are like, germs don't exist. And I'm like, I'm not saying you're saying that. I'm saying that like the gut biome literally does exist. So sometimes people out there, they're like, these things don't exist. And you're like, pretty sure that bacteria. And that's what that's toxic bile paradigm. That's where that comes in. Feed the gut bacteria toxic bile all the time. They get meaner and nastier. Make the bile more toxic with things like, nickel. They get meaner and nastier. We see all that research on it now. So yeah. So I when I get into it, like, do I think like Jamie Andrews research, and hopefully Jamie, if you watch this, I'd love to go on your podcast again, but Jamie is showing like that the pictures that supposedly that show viruses are the same from things that could not have viruses in them versus the ones that do. And he's showing that they look the same. And he's showing that, the virus tests are coming up positive on all sorts of things where they know, like literally sterile vodka is testing positive for viruses. So he's showing that all of that is like literally made up. And then when they get into the genomes and they're running it through a computer, and it's like, seriously. So yeah, viruses, I'm not a big fan of. Parasites exist. They definitely exist. We can literally see them get pooped out. If you guys don't know, people who do our program literally poop out parasites without trying to kill them. Because why? I want you to think about when we're talking about pathogens and we're talking about the terrain or the environment or however you like to put it. I don't get into the minutia and the mental masturbation of the terms as much as people want to. I don't find that moves anything forward. If you think, so I like to do a lot of car analogies, but I'm going to do a little war analogy. Because let's say you're trying to remove, we could say kill, but let's say you're trying to remove pathogens from your body. Okay. People use the made up Herxheimer reaction theory, which is garbage. Herxheimer reactions, folks, if you don't know, it's because you took something toxic and you're literally having a reaction, a side effect of taking something toxic. It is not because, I want you to think about this, really want you to think about this. There's bacteria in your body and you take a pharmaceutical or you take some pretty toxic herb and all of a sudden you feel like hot garbage. Oh, I'm herxing. Okay, literally, like I want you to think of war. Like if there is a person who gets shot and they die, are they decomposing right away? And are their guts and toxins spilling out everywhere? No. Do you literally think that if a parasite was in your gut and you killed it with something, it died, that it's been living in your gut for how long? Just fine. Once it dies, suddenly start melting and spilling out toxic stuff everywhere? No. There is not any evidence of a Herxheimer reaction in the literature at all. So if you are getting a bad reaction from taking, if you literally take something to kill something else, you are taking something that is a poison. If you do too much of it, you might get away with it because you're big and you can take enough poison to maybe kill something off inside of you. Well, you probably cause some damage to yourself, but you don't die. Like, I mean, literally, people drink caffeine and take nicotine, which are pesticides, to get high in a way. It's a pesticide. Literally can kill bugs, and bugs avoid it because they know it's toxic, but you can take it to get high. Do you see the difference here? So if you take herbs and pharmaceuticals to kill stuff, you're literally taking a form of poison. And you're wondering why you feel bad. I know. So Herxheimer reaction is garbage. We literally take people get off their stainless steel cookware and then they start getting symptoms. Like, do we really think, do they have a stainless steel deficiency? No, they don't. Did we cause them to herx? No. Do I think that, so here's the idea here. Here is how we get rid of pathogens. If you were you've heard of sieges, right? They used to lay siege to castles so the people in the castle, their enemies would surround the castle so nothing got in and out of the castle. Okay. Now they would probably be dying from their own filth because they didn't have plumbing and other stuff like that. But what were they trying to do to them? They were trying to starve them. They were trying to starve them. So I want you to think about what's the best way to avoid fighting and to avoid Herxheimer reactions. And the best way to get rid of pathogens so that they cause the least damage in your system and on the way out, if you believe in Herxheimer reactions. You starve them. That's it. That's the best way to get rid of pathogens. What did we just go over today? That certain bacteria and fungus and mold and virus. Okay. So I want you to think of your gut biome as a garden that you're trying to grow the right things in, right? You want to grow good stuff in the garden. You don't want to grow weeds. Very simple. You want good stuff. You don't want bad stuff. Okay. The normal approach, this is crazy. Like this, I hope this makes a lot of sense to you guys. The normal approach that people do to their gut is they first go starve it, like no carbs. You live on carbs too, but they're like, starve the bacteria. Go on the Candida diet, like starve it. Okay. So you're starving your own tissues too. And if you don't, I don't know if you know this, but there's actually literally studies out there where if you don't eat soluble fiber or carbs, your gut bacteria literally eat your intestinal lining. I don't want that because they get so hungry and you're not feeding them. And so they're going to eat something. So they're not going to starve. They're going to find something to eat. And then how many people have done Candida diets out there and they get off of them and their problems immediately come back? What did they cure? Nothing. Candida is naturally occurring in your system. So why would it go away just because you stopped eating carbs or fruit or vinegar or mushrooms or whatever? So first they try to starve it, right? And then they're going to spray their garden with toxic stuff. They're like, I don't want stuff to live here that's not supposed to be here. So they take things that are toxic, whether it's pharmaceutical or whether it's herbal or whether it's orthomolecular or whatever, and they take a bunch of it and they spray it all over the garden. And then they're like, okay, so now we're going to take fermented foods and cultured foods and probiotics and we're going to throw them on the garden. So now we've been starving the garden. We've now sprayed it with toxic stuff. And then we just throw some seeds on it. Hopefully they're going to grow, I hope, in your toxic, starved garden. And then people wonder why they don't fix their gut problems. So what we are going to do is we are going to do something different. Is we are going to not, so there's a very important concept in garden. The garden grows. What does the garden support? Does your garden support parasites? Then you get parasites and they stay. Does your garden support E. coli? Then you get E. coli and you get whatever comes along with it. If it supports Candida, same thing. Women are more toxic than men. Women get more Candida infections than men. They also, did you see that about copper and nickel? What's one of the biggest toxic, we got Kupfer, copper, and then we got Kupfer nickel, which is the devil's copper, which is nickel. Women detox slower than men, so women get more of these infections, urinary tract infections, Candida infections. Are you following it now? So what do we want to do? Well, we want to feed the garden, right? But here's the issue, right? If you grow a garden, you want the soil to support what you want to grow. So if your soil won't support what you want to grow, does it grow? No. If you talk to any gardening person and you go, this isn't growing or it's not growing well or it's whatever, they say, well, let's check the soil first, right? They might ask something silly like, do you water it? But after that, they get to the soil because that's what supports it. Now, if you have good soil, right? Do weeds still like good soil? Weeds love good soil, right? It's not like good soil is going to make the weeds stay away. But if you spray toxic things to kill the weeds and you also kill the good stuff, then you don't get to grow anything. So what do we want? We want our immune system and the number of good bacteria. We want to have our garden grow good stuff so well that it outcompetes the other stuff, so that the other stuff just doesn't have room to grab a hold and build. And we also aren't feeding it purposely. So then you get to have the things in your garden. You get to drink your water. You get to eat your foods. You get to starve the bad guys. You get to support the good guys. And then you fix your leaky gut. and you fix your allergies and you fix your toxic bile and you fix all this stuff, and then your gut problems are gone. And you don't have to take probiotics every day, and you don't have to eat cultured foods every day, because the idea is once your garden is going and you're doing the right things, it is self-feeds. It does the weeding. So if you think about that in your gut, if they say like 80% of your immune system is in your gut, why is 80% of your cleanup crew in your gut? You want a clean garden. So if you are immunocompromised because, I don't know, toxicity like nickel toxicity and vitamin A toxicity and copper toxicity and all this cobalt toxicity and all this stuff, your cleanup crew sucks. So you don't weed as much. So the weeds can grow. This is how I don't know why, like, I was one of the first people to kind of come along with this idea, because everybody's just like, kill it, murder them. And I'm like, that never felt good to me. And it didn't work. How many of you out there have done all these gut protocols with like the massive amounts of glutamine? Do you know what glutamine is? Wait, Kelsey, if you're watching, send me that glutamate study. The GERD and the peptic ulcer, or the H. pylori and the H. pylori and the glutamate. Actually, maybe I can find it. I might have it here. Let me see. There it is. Oh, cystic fibrosis and nickel. Okay, cool. So so I just wanted you guys to see this. So we went over the pectin thing, right? The pectin helped with Pseudomonas aeruginosa, which loves nickel. So pectin helps absorb nickel, which would then steal it away from the Pseudomonas, and the infections were less bad with the pectin. So here we have, so you guys know we're a big fan of MSG, as in glutamate, not glutamine. I want to give you a quick education if you don't remember. Glutamine is literally glutamate with an ammonia on it. What were all these bacteria making to protect themselves again? Oh, lots of ammonia? So you see why I'm not putting glutamine in, and all the other thing was the hydrogenases. I'm not putting in molecular hydrogen. That literally feeds these bacteria. It's how they modulate their environment, and they use the bacteria use their urease to get nitrogen for energy, and they use it to make ammonia to protect themselves. And there's an ammonia, and they can bind together, and then it creates glutamine, but you didn't add any ammonia to the system. Do you understand? So all these gut healing protocols where they're giving you like 10 grams, 20 grams, 30 grams of glutamine a day, why they never worked was because you were literally eating tons of ammonia. But what happens to H. pylori when they get some glutamate? Well, here's a statement in the abstract. Exogenous glutamate supplementation. I could say that as MSG on your food. Protects against gastric mucosal injury caused by H. pylori. Wait. Okay. So H. pylori makes urease that it needs nickel to do, and the urease makes ammonia, which damages the gut lining, and glutamate can scavenge ammonia. Are you following? Let's see. The results of in vivo and in vitro experiments showed that H. pylori infection induced gastric mucosal injury. Yes. This was accompanied by a reduction in XCT activity, which was attenuated or reduced by exogenous glutamate treatment, as in glutamate coming in from the outside. I don't know if they used L-glutamic acid, I don't remember, or MSG. Doesn't really matter. It's the same stuff. Glutamate as an extracellular signal mediator in peripheral tissues by autocrine and or paracrine might play a protective role in gastric mucosal injury from acute aspirin irritation. Peters, aspirin's not going to save you. Like, figure it out. Jeez. And cold irritation. Exogenous glutamate supplementation might have beneficial effects on gastric function. That's been shown in research. I think that we went over that in the MSG article. MSG is good for your digestion. For example, dietary glutamate supplementation improves gastric carbon incorporation rates, and nutrition management in post-weaning pigs. I think we went over that paper. Supplementing partial enteral nutrition with monosodium glutamate, irritation, and cold stress. Don't drink cold drinks. Don't eat cold foods much. Don't drink cold drinks. Stop putting ice in your drinks and then wonder why your stomach and your digestion suck. Think about this. You have a bucket of ice cold water and you put your hand in the ice cold water and you leave it there. What happens to the mobility and the sensation of your hand? Does it go up or down? It goes down. You get numb if you do it long enough, and your muscles don't work as well. Okay, your stomach is a muscle bag. It's literally a bag that's a muscle. What happens when you think you put in a big old glass of ice water or, God forbid, like soda? What do you think happens to the function of your stomach now? And now it's just the muscles on the outside, and the cold liquid is just making it cold. And your stomach is supposed to move and move your food. Well, if it can't move because if it can't sense well, because you're numbing it with literally ice cold liquid, and then it can't move well because you're inhibiting it by drinking ice cold liquid, your digestion will suck. So stop drinking cold drinks. Don't eat cold foods in general, other than rarely. Like, if you got to have some ice cream once in a while, that's fine. But if you ever notice, if you have like ice cream or other stuff after a meal, it will ruin your digestion. It will absolutely ruin your digestion. Another thing the Peters have to fix, but the number of Peter mistakes is just too many to count. So, yeah. So we got that now. Just Andy commented. Just Andy was the alginate wash. He said, I'm taking a break from the slimy alginate body wash / shower. It seems to stir something up and reduces my sleep, maybe once a week from now on. Yeah, isn't it crazy that you could do something topical and it might affect your sleep? It could also just be the nickel detox. You said he's still using the alginate slime for your shaving. Cool. Let me just go. I'm going to do a quick search here. We're going to go nickel cystic fibrosis. Let's go see what we get. Of cardiac CFTR chloride channel. I believe that CF may be, no, yeah, cystic fibrosis, transmembrane conductance regulator. So this is like a real mechanism paper. It doesn't really help us at all. All we know is that nickel inhibits adrenoreceptors. Okay. And it's going to mess with the heart. I'll have to find the other study. I found another study showing that nickel causes muscle weakness in the diaphragm. Gosh, do you know anybody these days with breathing issues? Like bad breathing patterns? Let's go look at this. Well, this is not very exciting. One case study, contact dermatitis is not previously reported in association with cystic fibrosis. We present the case of a 19-year-old non-atopic, so they didn't have allergies, with cystic fibrosis who experienced erythema and vesicles in an area exposed to nickel. Okay, that's just one. That's not anything. What is? Oh wow! I got the baboon syndrome due to nickel. I just got to look this up. The baboon syndrome. Don't get the baboon syndrome. The baboon syndrome is a rare variant of systemic contact dermatitis and is characterized by general exanthema and with particular involvement of buttocks and flexures. Here we present a 25-year-old female with contact allergy to nickel who developed baboon syndrome after systemic administration of this allergen. She had systemic administration of nickel? Okay. Okay, so let me get to that, Joe. Let me find that super chat if I can. Wow, we got a lot of chat. I'm not going to try to, just because, I mean, I think the plants make more carotenoids to protect themselves. It's not for our benefit. It's there's literally no physiological function of carotenoids in the human body. That's why they can't make a claim on supplements that like beta carotene helps anything. There is literally no requirement for carotenoids anywhere in the human body. And people will say, "Oh, they protect you from the sun." Okay. Did you ever see the carrot oil lady? Let me find that. So if carotenoids were skin protective, right, then carrot oil should help us not get burned. But this was a story a while ago. I went over, I don't know if this is the article I went over, but mom left looking like drumstick lolly after cooking herself with carrot oil. Laura Bevan was left with third degree burns on her legs after sunbathing for 7 hours with nothing but carrot oil on her skin. And this is in the UK. So anyway, what I'm getting at is, I mean, so the plants in the tropical areas make the carotenoids for their benefit. Like plants are not necessarily, they're not making a lot of stuff for you to benefit from. Like the nickel accumulation, I think I went over the nickel accumulation as a defensive. Where is it? There it is. Like I remember this paper, the ecological significance of nickel hyperaccumulation, a plant chemical defense. So like they're accumulating nickel to defend against people eating them. Like everybody wants to think that like, oh, we're supposed to get along with plants, and the herbalists are just the craziest. They're just like, which plant toxin am I going to use on you today? Oh, let's make a tincture of plant toxins all together. And oh, just don't take too much of that one, or it's cardiac glycoside. It might kill you, but if you take just a little, it'll help. I'm like, seriously? So what I'm getting at again, so the plants have to defend themselves, literally. And there's more carotenoids and there's more sugar. Those go together. Yes. The sweetest foods tend to be the more, I won't say his name, but he's a doctor, and I met with him and his lovely wife, and he was talking about how down in Costa Rica, they were eating all these like brightly colored fruits and vegetables and all the stuff that they ate down there. They said everyone down there was literally red. Like they were tan, but they were red. And he got the same way. Everyone down there looked sick. Like Liver King sick. So do I think that it's good for people down there? No, I think that the plants are willing to defend themselves more with that. And that's why they make more sugar, so the animals will still eat it. And hopefully poop out their seeds in a nice little, think about this. Okay. So if the plants get their seeds pooped out and lactobacillus literally grabs onto nickel and carries it out in the poop, then boy, that makes it even more of a nickel fertilizer for these plants that might use it as a chemical defense. So we just see people if they had issues with the sun before, whether they were dark-skinned or not, because dark-skinned people can still get burned. People's tolerance of the sun gets better the less vitamin A they have in the system. They don't burn more, they tolerate the sun more, and that includes carotenoids. So I see where your question's kind of coming from, but do I think there's any, like, is there literally a correlation? Yes. Do I think that eating more carotenoids living by the equator is good for people? No. So there you go. Oh, Beth was saying she had braces and chronic tonsillitis and a ton of cavities. We're seeing this a lot. So, and Beth, you had a lot of nickel detox dumping symptoms too. So, yeah. Beth is saying, any idea if ferments have the right lactobacilli? No, but there's actually, I forget what they call it. Is it biological transmutation or transformation, where certain bacteria in your gut can turn into other bacteria? This is in the research. So when people like think you have to take this probiotic to get it back down in your system, no, like other bacteria could literally transform into what you need. Why would they do that? If we change the environment to what it's supposed to be for that, right? Val Zim is saying, to put it another way, bacteria do not cause disease. Disease causes bacteria. Yeah, we could look at it that way. I just don't. The disease causes bacteria, and they go, wait, I don't understand that. That doesn't make any sense. That sounds crazy. Then they just leave. They turn their brain off and they just go. So, because it's too far out there. So I would tend to want to show like toxicity. Most people know toxicity is bad. And that toxicity isn't good, and toxicity can make you get sick. Okay, then we go, okay, so the toxicity then makes the bacteria bad. And the toxicity may be the cause of the bacteria becoming bad in the first place, or even showing up like that. So that's just, it's a different approach, Val, that I do. I'm trying to, like, nobody's talking about nickel and disease and stuff out there. So, oh, we got that cystic fibrosis and nickel. CPG says, don't take our cold drinks, man. Americans are like the only people who drink ice in their drinks. Like, why are we the weird ones? And then we're so sick. Like, we have to look at the silly things that Americans do that make us so sick. And now we've got everybody's legalizing hallucinogens, and they're like pushing nicotine, and and the weed stores are on every corner. And it's like, they are in full on destroy America mode. It's full on. The no cash system is coming. I put this on Twitter the other day. I talked to a used car salesman guy, and he was saying that in Idaho, I said, would you rather have cash or a cashier's check or a check or whatever if I was going to buy something? And he said, well, I don't want cash because the bank charges him 2.2% interest to deposit the cash. The bank charges you interest or a charge to deposit cash. So they're trying to discourage cash that way. There's also the whole no pennies thing anymore. But then I was in a restaurant just yesterday, and giant sign on the wall and a sign inside the menu saying, we're going to have to say it, we're breaking up with cash. And so they were literally saying, they said at January 1st, they stopped accepting cash entirely. And they're like, oh, it's for everybody's benefit. And I'm like, I personally was just like, I'm never coming here again to this establishment. It used to be locally owned, and now it's owned by a big restaurant group. I didn't know that until we sat down. And the large restaurant group is probably doing that in all their restaurants, because you don't get to become big unless you allow yourself to become controlled. That's the rules these days. So, yeah. Sorry if they make more melanin. Sorry if that wasn't clear. Did you know that melanin binds the toxic metals? You can go look it up. Melanin literally binds to toxic metals. So is it a good thing to have more melanin or not? It's an interesting question. So yeah, it could interfere with. Oh wow. Yeah, Julia, you just gave me a good idea. She added, as I've learned from you, the UV helps break down the vitamin A in the skin, and dark skinned folks are exposed to high sun all the time. Okay, let's connect this as sometimes only it seems only I do. Have you guys ever heard that African Americans have lower vitamin D levels across the board in general? This is known in the literature. Like one of the problems is they're trying to say, well, the guys who actually pay attention to health and not just labs, they're saying maybe we aren't supposed to push black people's vitamin D levels up as high as white people. Like maybe they're not supposed to be there. Maybe they're supposed to be lower. Well, as you just brought up, the dark skin could protect against the UV so they don't break down the vitamin A as much. Okay. What is vitamin A an antagonist of? Vitamin D. So the more vitamin A you have, the lower your vitamin D levels. If you can't break down the vitamin A, you're going to have lower vitamin D because you got more vitamin A and they are antagonistic. And then shoving a bunch of rat poison vitamin D3 pills down your throat isn't going to change the fact that there's too much vitamin A around. So we just probably connected that. Darker skinned people having lower vitamin D levels is possibly because they can't break down the vitamin A. They've lost a lot of that detox option because of their darker skin. Not that they chose it. It just is the way it is. So, okay. You're welcome, Julia. Let me see this. Okay. Luca says, hello, Dr. Smith. I've come across studies showing how grass pollen and tree pollen's protein in cities is altered due to being contaminated constantly by nickel. And pollen allergy is actually nickel. That would be interesting. Do you have any links to those, Luca, that you could put in the chat? I'll go do my quick search. Oh, wow. We may have something. Let me see. Well, this is just the first one I found. They said nickel patch tests served as an established model of contact dermatitis. Like you're going to get irritated if they put enough nickel on your skin. You don't have to be sensitive. Discussion. Thus, pollen grains induce eczematous reactions in susceptible individuals. This reaction appears clinically and immunohistochemically similar to the contact hypersensitivity reaction to nickel, but follows a faster kinetic and biphasic course. What if there was pollen in nickel or nickel in pollen? Wait, what is this? Well, I don't know if I'm going to be able to go find this whole paper. Intrinsic, as in native, atopic allergic dermatitis shows high serum nickel concentration. Oh, wait, is this free access? Let's go see. Elsevier, will you give me free access? Please. I am a human. Are you a human? Anyway, intrinsic atopic dermatitis shows a high serum nickel concentration. And there's no abstract here either. Oh, wait, it's just a letter. Okay. Female predominant is noted in IATRA, what'd they call it? IAD, serum IgE normal intrinsic atopic dermatitis. So women have more of it. Ladies, you're just more toxic and you've been wearing earrings since you were 3 years old and jewelry and cosmetics and IAD patients often suffer from metal allergy. Let's find pollen here. Is it in here? Pollen's not even in here. Oh, whatever. But I want to know what they mean by intrinsic exactly. Like, what do they mean? Extrinsic. So we got extrinsic atopic dermatitis. And then we got intrinsic atopic dermatitis. Here, I'm going to do a quick search because I want to know this. Here, you guys can see me do it. Not hiding anything. What is the difference? Because I don't know. Extrinsic. Let's see. Most of it's extrinsic. Okay, 80%. Intrinsic just means that they can't figure out. Back here, and we go intrinsic, the one where they can't figure out a cause. Atopic dermatitis shows high serum nickel concentration. Well, there you go. It's like when they have idiopathic intracranial hypertension in babies and the kids' heads are all swollen, and they call it idiopathic because that means they don't know what causes it, when vitamin A toxicity is the main cause of it. We don't know. We just have all this research. We're just going to act like we don't know. Don't rock the boat. They'll kick you out of the hospital. So anyway, Joe, was Luca able to post any other research on that? I mean, I'd love to see it. I would love. Oh, it got rid of my tab. Okay, who cares? No, okay. So, actually, wait, let's do. Let me do something here. Let me do pollen content of nickel. Let's see if there's anything. Oh, just wait. Oh my gosh. Just wait until next week when you see the connections between glyphosate and nickel. Oh my goodness. Oh. Insane. It's just like when they can literally poison you with copper sulfate on organic crops. They're spraying copper sulfate on organic crops, the parts that you eat, and people aren't magically turning healthy from their organic foods. They can literally spray, there's nickel sprays for plants to protect them from getting ruined by glyphosate. We'll go over that. So nickel content in pollen. I just did this quick little AI search, okay? A study of bee pollen samples from Jordan found nickel concentrations ranging from less than 0.01 to 2.839 milligrams per kilogram. I'm going to guess that that's a pretty high number. Oh, exceeding the acceptable limit of 1. And there was higher in industrial and desert areas. Oh, great. I got to move out of the desert. Generally had higher nickel levels than those from agricultural zones. Well, that makes sense. Plant-generated pollen. So when they supplemented the plants with more nickel, the pollen could have 10 times as much nickel. Oh, wow. Nickel accumulation in floral rewards like pollen can reduce floral visitation rates by pollinators such as bees and flies. So the bees and flies know to avoid it. They don't want it. So there's that. Okay. Joe, is there anything else? Yeah, Jackie. So Sergio, I want to ask you this because Sergio says I've been losing weight during the low nickel diet. Was it the nickel for the extra kilos? I don't know. And he put a smiley face. So I'm going to say that Sergio is happy for losing the couple of pounds. On the testimonial I went over a couple weeks ago, a gentleman from Twitter was saying that he was like maintaining his muscle and losing fat. Well, I'll say it now. I actually have been pleasantly surprised, like actually kind of mind blown. I remember I've been on this longer than most of you guys, and I've been pretty aggressive in my stuff, but I am at a body weight of like 203 right now, which is like, okay, so when I think of I want to be lean, I want to be like 190. Okay, that's like that. We get used to our numbers, right? We have our weights where we're like, I know I look good at this weight, and this is heavier than I wanted to be. Okay, so I weighed myself the other day. I was 203, and I'm looking in the mirror going, this doesn't look like 203. This looks pretty good. Like I should not be this lean at this heavy. And I'm just going, it's got to be the nickel. So Sergio, I'm going to say it's the nickel. For those of you out there who are hoping that this will help with weight loss, it will. Give it time. For those of you who want to gain weight, you're underweight, give it time. I don't think the weight stuff is the body's priority. So it will tend to come later. Like I know the testimonial the other week, he'd been doing it for several weeks and it had been happening. But again, remember, he's a guy. It happens faster for guys. Ladies, you go slower, and you've been poisoning yourselves with nickel more and for longer than the guys, and you're slower at detoxing. So just, as the term goes, settle in, keep going. As the Winston Churchill saying, I like this saying. I don't care what you think of Winston Churchill. The saying was, if you're going through hell, keep going. So I'm going to tell you, if you jumped into the low nickel diet and you're suffering and you're going through the detox dumping, I can tell you my buddy who I talk about a lot, he's coming over the hump. I can tell he's coming over the hump. His complaints are going down. And he's starting to see improvements, and things that he was having symptoms with are getting better. So the hump does come. It's not, so remember, it's like going up a mountain and coming down the other side. Like when you come over the peak, you're not done. It's not like it's all just over. You're going down the backside, and it'll take a while to get down the backside. But I can tell you that when you get over it, you'll just keep noticing more and more improvements. That's all. It's just things will go away that you've had forever, and symptoms that have come up during the nickel dumping will get better. And then I think after a while, the weight, and the thing that I'm hoping to see is like the hair filling in and the gray hair going away, because we already connected that multiple ways to nickel toxicity. Your body doesn't care that much about your hair. Like you may care, right? We care, but your body is survival mode. And if your body's like, look, dude, you're over 30, your main kid years are over, who cares about your hair? Like, we're just trying to stay alive here. So you got to realize that hair fixing stuff, in terms of like true nutrition and detox and supplementation, it's probably going to be one of the last things. Like our vanity things are very important when we're young, which is why young people tend to look better and stay healthier, because they're just young and they haven't accumulated that stuff by the time they're done with their childbearing years. And so when you're done with your childbearing years, and some of you out there, you know, almost all of us are going to kind of whine and go, well, it used to be so easy. Well, you used to be less toxic. You used to be younger and you had a better detox system. You're here. We are fixing it. And this is one of the biggest things. So let me see. But yeah, the losing weight, that will come. Like I said, Sergio, it's going to happen for guys probably before you ladies, but it is coming. And I will tell you, you don't have to eat as like you may. Here's what also I can tell you. I look leaner at a heavier body weight, and I have not been super high protein or anything like that. I've actually been eating more carbs. And that's what the other gentleman said on that testimonial earlier. So I'm kind of sitting here going, this is not what I was taught. But I think a lot of the things we were taught were compensations for the toxicity that everybody has. And at some point, the compensations, even that you keep lowering your calories, like I was talking about, people are like, calories in, calories out, and it always works. And it's like, maybe not. Or maybe there's an easier way. Oh, you know what I did? Actually, I have Macrofactor, the food tracking app. And there was a period of weeks, several weeks, 2 or 3 weeks, where I just got sick of tracking it, because this was the thing that was confusing me on the low nickel diet. Like, I could feel like I was losing fat, and I could see it in the mirror, and my weight was not going down. And so the app kept taking calories away from me, right? It's saying, this isn't working. It's not working. We better cut your calories down. And I was like, I had to make a decision. I'm like, okay, we're going to change our goals in the app, because I'm perfectly happy with where I'm at. And I'm not trying to lose weight, or at least not trying to lose it quickly. So I totally changed my goal weight, and then it changed my calories, and now everything's fine again. And I'm going, this is great. So it does come, folks. Monitoring your calories can be good on the low nickel. It ruins your appetite a lot of times. So if somebody said, well, your appetite got less, that's why you lost fat, Dr. Smith. But how did I gain body weight and lose fat? If I lost fat and I gained body weight, what did I gain? Oh, muscle. Oh, well, maybe next week we'll go over the testosterone that nickel shreds. Oh, and growth hormone that nickel shreds. What does growth hormone help with? Muscle mass and losing fat. So we're going to help your growth hormone levels get better. This is the biggest thing to ever happen to the health world, in my opinion. And I've been in this game 20 years now. I mean, well, before that, I was in the personal training game. I've been in the doctor game for 20 years now. So this is really, just remember, prep yourself for the low nickel diet. Don't just jump in if you're fine with suffering. I mean, if you don't realize how bad the suffering is yet, or it may be for you, I mean, you can do it. I'll just say, I told you so. So, let me see this. Okay. Val, thank you for that. Let me find that paper. Here we go. Concentration of heavy metals in pollen and bees in 3 different habitats in, I don't know how to say that, Lowick district in central Poland. So the bees are going to be the biomarkers. They're going to see how toxic the... Okay, so they're saying there was no significant differences. Well, this is not a very exciting study. They didn't find any differences. Were both recorded for orchards. 0.16 milligrams per kilogram and 2.37 milligram per kilogram, respectively. So there can be plenty of these values were almost twice as high as those obtained by Bayer and Agan in Turkey in 2022, and bees from urban areas almost 4 times higher than in the rural area. A nickel concentration above 0.3 milligrams per kilogram in bees is a disturbingly high concentration according to the proposed standard for honeybees by Gutierrez et al. In 2013. Gosh, is it the glyphosate killing the bees, or is it the wow, no, I'm sorry. I can't believe I missed that, Val. Wow. So this guy suggested 0.3 milligrams per kilogram. A disturbingly high concentration. So we have 0.74, 0.86. This one is below. This one is 8 times as high. So, yeah. That can't be good. Sorry. Okay. So Sergio was saying also, he was asking a question about could a pokey change behavior in a child? Absolutely. Yes. Absolutely. In some small observations, it seems that, well, often as people get less well or they get sicker, they become more introverted. And I think we're starting to see that pattern more with, like, I mean, we know in the research that nickel causes anxiety and depression. Those would tend to be things that people don't want to share. And so they may start staying home more to avoid, having to expose themselves, their anxiety and depression, than that. So, but yeah, could a pokey change a child's behavior? Absolutely. Yes, absolutely. Actually, Kelsey and I have talked, and we both have a bit of an uneven smile. And some of you may know the French doctor, or was he French Canadian, who showed all the pictures of the pokey damage to the cranial nerves. And I think I had some from one, and Kelsey thinks she had some from that. But yeah, does anybody know like, he was like French Canadian, I think, the doctor who I think was supposedly unalived for showing all of this. He had tons of pictures of all these babies who, their eye was drooping or their mouth was drooping, or somebody here knows who that is. I know it. But yeah, if a toxin can literally change your face, it can change your brain. If it's changing a cranial nerve, like cranium being your brain case, right? It's changing a brain nerve. It can change behavior. Absolutely. Yes. I mean, they know blood transfusions can change behavior. Organ transplants can change behavior. Like, you're taking a part of another person, you're putting it into you. It changes the vibe, let's say. But yeah, you said after her pokey, you are the expert on your child. No one else is the expert on your child. So you know what happened. Time-wise, does it make a good connection? Yes. So, oh, wow. Okay. Joe, can you highlight that one? Or should I go find it? Here, I'll go find the zinc. Let me see. B samples differed only. Okay, let me go find that. There we are. Oh, I didn't even. So the B samples differed only in their zinc content, which was significantly higher in orchards than in urban habitats and the berry plantation. They were probably, I'm guessing that the orchards were somehow supplementing their soil with zinc, and it made it up into the pollen and the plants, and then that got into the bees, because they're literally talking about bees here, not the pollen. So, and one of the this was, I'm guessing this was the average in the orchards versus the urban and the berries, and then the other one, the orchards had the highest, potentially highest. There it was. Orchards had the very highest nickel value. So again, maybe the zinc was protecting the bees. Disturbingly high, 8 times higher than the suggested limit. So yeah. Thank you, Val, for pointing those things out. Okay. Matthew Jones says, can we find the study on scurvy in dogs or humans, please? I'll do it. Let's see. We'll see if Sci-Hub has it, if I can find it quickly. It should be in the document with the in the scurvy. Vitaminosis A dogs. Well, here, I'll share this. So let me see if this is it. Oh, vitamin D is good for you. Here we got changes in oral structures of the dog persisting after chronic overdoses of vitamin D. Oh, so now we have excessive vitamin D can literally change your skull and your mouth. We have another toxin that can change your skull or your mouth. Just take too much rat poison. Then we also have hypercalcemia in 2 dogs caused by excessive dietary supplementation of vitamin D. Dietary supplementation. Severe calcification of mucocutaneous and gastrointestinal tissues induced by a high dose administration of vitamin D in a puppy. Anyway, let me see if this is the that's a pretty. Let me just try scurvy and dog. Let's just try vitamin A. Oh, sorry, I'm not showing it. Anyway, this one's here again. I'll have to look in my old. Might be time to redo my. Actually, wait. I got one chance. I don't have more than one chance. I'll just see if I can get it. Okay, so now these are the papers we got to find. Vetter and Rosenberg. What was it? Hypervitaminosis. Oh, come on. It's not even here anymore. Let's see. Let's see if we can find it. If any of you guys want to go searching for that, you can. I don't think we're going to find it today. Oh, here it is. Wait. Here we are. This is one of them. There's another one. Is this Vetter? This is Rodal. Oh, yes. Rodal was the guy who wrote the 50-page study. Oh, I got to share the screen. Sorry. Thanks, Joe. Can I move this? The similarity between the clinical picture of hypervitaminosis in rats and that of scurvy has been pointed out by Vetter and Rosenberg, who found that ascorbic acid offered protection against excess of vitamin A. And also by Moore and Wang, who failed, however, to detect the abnormality in the ascorbic acid metabolism in their hypervitaminotic rats. So, so they gave these rats tons of vitamin A, or as an extension of this is Rodal's study. The condition of hypervitaminosis A has been subject to detailed studies in rats, mice, guinea pigs, rabbits, dogs, and chicken. That's what he did. Within a few hours after a single dose, in the range of 50 to 100 IU vitamin A per gram body weight, symptoms of acute intoxication have occurred in the form of general malady, changes in the pelts, drowsiness. Wow, their pelt changed in hours. Drowsiness, muscular weakness, and decreased activity. Continued administration of the same dose during a longer period caused symptoms of chronic intoxication. A number of these clinical symptoms, as well as post-mortem findings, so the autopsy, were identical with those observed in human scurvy, such as muscular weakness, pain in the limbs, scattered small hemorrhages, apparently due to abnormal capillary permeability. Blood. I'm not going to look for it now, but you'd want to find the Vetter and Rosenberg. Okay, so here's this. So take a screenshot here and go and look for 1 and 2, Moore and Wang and Vetter and Rosenberg. And that's where they mention the dogs. So if you can go and find these, this is what you want. And then if you can find Rodal's classic paper, here's his last statement. It is thus evident that prolonged administration of excess of vitamin A in experimental animals produces a condition which resembles scurvy. Although abnormality in the vitamin C metabolism cannot in any way be considered as the sole causative factor in hypervitaminosis A. So, Joe, I'm going to send you the link so you can post it, because scurvy's coming back, folks. I don't know if you heard this, but scurvy is coming back. But what if it's just nickel toxicity is getting worse? Nickel toxicity directly inhibits vitamin A detoxification in multiple ways. And then people are seeing scurvy symptoms because, well, nickel is like a super oxidative toxin. So nickel would, in theory, if vitamin C was necessary, it would deplete your vitamin C. But vitamin A toxicity shows up exactly the same as vitamin C too. So am I going to say I know exactly what it is? No. Do I know how to fix it? Yeah. So. Oh, okay. Joe's reminding me we said no super chats earlier in the show. Joe, no one can contain me. Like I'm a whirlwind. So, oh man. Sergio says, Doc, my wife is exactly as your former wife. I told my wife not to give our daughter a pokey, and she did it anyway behind my back now. I kid you not. My daughter has way more separation anxiety. I'm sorry, man. I was serious enough about two things. I was very serious about two things before I got married the first time. I'm planning on doing it again soon. But one was no shots ever, none ever. And the other one was no circumcision. Those were the two like non-negotiables on my side. I was like, this is non-debatable. This is the deal. And I was lucky enough that she never did anything behind my back like that. I'm very sorry that that happened to you. And, you know, I don't know. Pointing, not being a jerk about it, but if there are ways that your daughter has changed since that, you might point those things out on a regular basis and say, okay, here's what happened. Let's not do this again. Like literally, you saw her before, you saw her after. Now she's like this. It will only get worse. Every time you do this, it will only get worse. So please, can we stop? That's about the best advice I can give you is you can only go forward from, I mean, you can work on her health. We can do that. Can we undo what was done? I think the body has the capability of doing that. Yes. But the biggest thing is to not, to not let it happen again, or to convince her that there's more risk than benefit. I mean, like my buddy said he got a pokey once in like a Walgreens and he turned green and basically passed out against the wall. And that was the day he decided he was not getting any more, but he was, probably 16 or 18 years old when that happened. And he said, no, I'm not doing this again. And, that's that. Joe was saying automobiles generate airborne. They're like breathing in. I don't understand why everybody has to leave their cars running and the fire trucks running. I don't care what the excuse is. Like you're literally poisoning yourselves and everyone around you so you can start the car faster or something. I don't know. Everybody's getting poisoned. Y'all are breathing. And then they're wondering why is testosterone low. I found like 5 studies on breathing in exhaust, lowering testosterone. I was like, did they leave the engine running in the firehouse a lot? And he's like, yeah, all the time. Like when they wash it, they're leaving it running. And I'm like, I don't understand the stupidity of this. Why is it running while you're washing it? And everybody's breathing in this toxic crap. So for what reason? But then again, firefighters are some of the most, well, not only do they primarily fall under a certain ethnic group, but they are some of the most giving people out there. So who might the bad guys want to poison first? Take that for however you will. So, Beth was, thank you, Beth. Beth said, good, Papa. I mean, I tell my boy now, I'm like, my boy used to have like pictures of my son. He literally wore a soft helmet because he would have these absence seizures where he would just check out. Like he'd be staring at you and you're like, wake up, dude. And he wouldn't wake up. And he did that a couple times where he was standing, he was literally standing, holding on to something, like infants do, little kids do. And I'm like grilling and he's just right behind me. And then all of a sudden I hear him crying and I turn around and he's on the ground. He had one of those and he just fell down. So, I mean, I was telling my son, I said, you just be really glad that I never let you take one of those shots, because I knew as a knowing what I know, I was like, if they give him one, he's gone. He's like just gone. Not going to let it happen. Now, they're not the only cause. Toxicity can cause it. Ladies, they're marinating in you for 9 months and you guys have already dealt with the toxicity. But those kids, like, those shots are just toxins. So they just add toxins to the load. So if all of a sudden you get a poke of enough toxins, things change. But you can get there with enough toxins, especially in utero. So this is what we're trying to fix. Lucas said, thank you for your answer, sir. Sincerely, you're very welcome. And then what was the other one? Oh, Beth was saying, I often ask people to turn their cars off when they're idling. They don't seem to love it. LOL. But they'll do it, right? So they don't have to leave it on. Like, there's no requirement that they leave it on. Normies, man. Like, oh, it's just like, I can't even understand the level of stupidity to leave a car running and the exhaust billowing out for all of us to breathe, knowing it's toxic. And then people are just like, what's the big deal? It's just exhaust. Like, oh, I don't understand that level of stupidity. Oh, I can call him that, Joe. That's okay. That's okay. So, okay, we're going to wrap it up. Thank you all for coming today. Let me get to the, oh, Joe, I might remember how this works. I don't know. What did I hit, Joe? I don't remember. It's the button. Oh, Joe's doing it for me. He's like, you can't handle it. Anyway, YouTube, this is our YouTube. You're probably watching us here on YouTube. Most people aren't watching us on Rumble. I run the right, the big T. I hit the T. It's not, there it is. I had to hit it like 3 times. Okay, here we go. So you're probably watching this on YouTube. If you come to this channel, that's our main page. On the home page, there is the Toxic Bile Paradigm series, the 3 video series that I did with Beth Martins. And then we're all into the nickel toxicity thing now because YouTube, and that's number 198, and that's on Rumble. So let's do that next. So Rumble is our second station, our backup station. That's where you can find all the videos, and none of the videos there had to be edited for the controllers that are on other big video channels. So there's that. Then we have Twitter. I'm on Twitter. I'm very tired of Twitter, but I may go back there someday if I ever feel like butting heads with a bunch of butt heads. Anyway, Val, thank you for coming here from Twitter. I met Val on Twitter. Thanks for coming, Val. You're not one of them. So our main website, let's get into it now. nutritiondetective.com. This is where you can find our supplements. This is where you can find our consultations, testing and consultation with Kelsey and Nathan. This is where you can find the link to the membership link to the Love Your Liver program. That's our main thing. We're working on all sorts of stuff about the website and shipping and marketing and all sorts of stuff right now. So stay tuned. It's going to be exciting. We'll start doing things more efficiently and more effectively. That's what's coming. Okay. There's my Facebook. We'll be probably marketing more on Facebook. The Toxic Bile Paradigm we already did. For those of you who are interested in the mouth guard, the Revive mouth guards, I'm wearing mine like every day. I got the R3, which is the big one. I think it's great. If you go back and you watch my old videos and my face is kind of a different shape and stuff like that, then the Revive is part of that. There was some mewing phase. There was some hard gum phase, but I think the Revive is really, I like it a lot. I think it's worth it. It's not for everybody, but I really like it. So then we have My Life's Work, the Love Your Liver program. This is a do-it-yourself program that has a social network kind of thing to it. So people can post and people can comment and do all that stuff. And we keep it fairly tightly controlled so that because most of the internet is a cesspool of trolls and people and antagonists and people who literally have their life to waste, wasting other people's time. We don't have that. We don't want that. They have the entire internet they can go on if they want to go bother people. I think of the Love Your Liver program as a country club versus a bus station. If you want to go out on the main internet and be in the bus station, then go ahead. If you want to be in the country club with people who are after the same goals and, you know, familiar with my stuff and chat about that, then that's what the Love Your Liver program is. Okay, then we have, if you want to sign up for my email newsletter and get the email series, madnessofmodernnutrition.com is that. You can also find the email newsletter sign up on our main website. Our shop, if you're interested in supplements, that's where you can go. The sun fiber I mentioned today is like, I really think that can help with the bacteria. I mean, you're going to be doing fibers as part of this, but the sun fiber is really, really useful. Make sure you get your zinc that you can get from multiple things that we got. For those of you who are doing the low nickel diet, the zeolite can really help if you get a flare up of digestive stuff. Dropping some zeolite down there can really, really help as a symptom fixer. So it grabs onto about 90% of the nickel when it goes down there. And if you have stomach symptoms, you got nickel floating around in there. So there's that. Let's see the glass. If you guys want to see the, actually, Joe, I need to put that link in the info doc. I just need to, we can post that in there so people could look up the studies and then go to the glass highlights. That would be cool. I should do that on all my info docs someday. Okay. Instagram. This is our Instagram, same as our Facebook. Let's see. There's our Substack if you care. Substack, there's only one more place that is more doom and gloom than Twitter, and that's Substack. For those of you who are into EMF remediation, I'll show you a couple things. Joe, I actually need to change that to Sarah Leilani. Sarah Leilani is our EMF solutions person. I did a video with her, I think, was it 249, 248, something like that. Anyway, I love their stuff. I have the personal EMF thing in my pocket right now. I've got 2 of them on my phone. I've got my whole house outfitted. I think it helps a lot. The long-term fix to your EMF stuff, Sarah does free consultations because this stuff works so well. You put it on your house, it lowers the stress in your body, and then all of a sudden you start detoxing a lot. I had this, Julie had it, like we have multiple people had it. So it's a good thing. You feel better after it. But if you wanted to know how to progress, like what parts are most necessary for your house, what's best for you, what's the best order to add them in, get the free consultation with her. She's great. I just ordered 2 of the iPhone chips for my brother's new phone because he wants to be protected. And I told him, I put 2 of them on the phone now. I don't mess around. One's cool. One's great. One's better than nothing. I want 2. I just want to I want the big guns. So anyway, that's about that. So let's wrap this up. Let me find that. I'm Dr. Joe. Joe's flipping them around for me. Go ahead, Joe. So this is the show. Hopefully go share this with your favorite terrain theory, anti-germ theory, what environment theory, whatever you want to call it. The people who think that the diseases as in what did you say, Val? I don't remember. Diseases create, Val said bacteria create diseases. Bacteria don't create diseases. Diseases create bacteria or pathogens. That's what we're after. Nothing grows unless you feed it. We're going to stop feeding it. It's very simple. And then you put in the good stuff. So this is Nickel Feeds Pathogens with the question mark. The hidden link to mold, Candida, H. pylori, and more. Don't forget to look at that info doc. If people want the references, it's all right there. Next week's going to be exciting. This was 253. Next week's going to be exciting. I have all sorts of stuff on nickel connecting to iron overload, nickel connecting to, Oh, breast cancer. Oh, the breast cancer connections. Ladies, let me tell you this right now. Stop wearing underwire bras. You're literally getting exposed to nickel. It's going through the bra. It's shown in the there's pictures, case studies in the research. Stop. And look, don't ask me for what to wear instead. I don't know. I'm not an expert in that. But they're figuring out all sorts of crazy stuff. So all I know is that there was a book decades ago. Some of you may know it. It was about the connections between breast cancer and bras, particularly underwire bras. And they were trying to say it was like electromagnetics and the conductance and the capacitance, whatever. They were trying to say it was from the wire electrically causing it somehow, like energetically causing it. No, it's literally the nickel going into your skin. That's what it is. So stop wearing underwire bras, but I'll go over all that next week. Okay. So, and for those of you who have babies, we'll go over this too. The snaps that are on their outfits, if they're metal looking, put something on the back of them, or don't have them wear those onesies or whatever. Okay. It's literally in the research. So either they're painted, they need to either be painted on, like the metal has been painted over, or you stitch something on the back of those snaps so that the nickel is not touching your baby. There's all sorts of stuff we got to get into. Okay. So we'll go over all that stuff next week. Hope you all enjoyed it. Didn't quite hit the 4-hour mark. That's okay. I'm okay with that. I will see you all next week. Have a great week. Bye now.